Hi guys, welcome to the live today, day before the GCSE paper 2 and the first A-level paper maths of this exam season. So it's going to be a bit of a longer live today because for the first part, I'm going to go through GCSE paper 2, the 2022 paper, and then for the second part, we'll do an A-level maths paper 1. So I've decided to do both of the papers I sat, so the 2022 GCSEs and 24 A levels, because I thought that'd be kind of fun to go through the papers I did when it was my exam season. Okay, so I'm going to get right to it. So we're going to do GCSE first, and that's a calculator paper, and it's the 2022 paper 2 if you want to follow along as well. So question 1, simplify x cubed to the power of 5. So you're just raising a power to a power, so you just do 3 times 5, and you get x to the power of 15. And that's it for question 1. 1a. Then 1b, expand and simplify this. So all you have to do is multiply the number outside the bracket by those inside. So first we do 4 times x is 4x. 4 times positive 3 is plus 12. And then do 7 times 4 is plus 28. And then 7 times minus 2x is minus 14x. And then you have to simplify it. So you have to clean up what you've done. That's 4x plus 12 plus 28 minus 14x. So you've got to collect the like terms. So 4x minus 14x is minus 10x, and 12 plus 28 is plus 40. So your answer is 40 minus 10x. It doesn't matter what order you put those values in, both are fine for that. For part C, factorize fully 15x cubed plus 3x squared plus y. So what I do with these types of questions is I first look at my whole number, 15 and 3. What is the highest common factor of them? 3. So I take that out. Then I examine each letter by letter. This question could be foundation, but this is a higher paper, Ruzish. Then I have my x terms, so x cubed and x squared. What's the most I can take from both at the same time? Well, that'll be x squared. And then can I take any y's from both? Well, this term doesn't have any y's, so I've taken out my highest common factor, which is 3x squared. Then what do I need to multiply this by to get 15x cubed? So 3 times 5 is 15. And then x squared times x is x cubed. When is A level? A level is from 7 to 8:30. Might go on until 9 since A level is longer. So that would be x. And then how do I get from 3x squared to 3x squared times y? I just multiply by y, and it's a positive, so I add that. So that is my answer to part C. Nice, good start to the paper. A little bit of algebra. That is for 5 marks. Hopefully this is making sense. I'm loving everyone's interactions in the chat. I appreciate it. Okay, for part 2. So if you were in my GCSE live 2 days ago, we did a really annoying transformations question, and I pointed out some tricks on how to recognize which sort of transformation you want to, it is. Is this the same for Australian curriculum? I'm not sure if the Australian curriculum is the same. This is the UK Edexcel exam board. If you might do IGCSEs for Edexcel or Cambridge, there are slight variations. I think IGCSE has more content, but I don't think there's any eliminated content. But I can't comment on internationals for certain. Okay, so the tricks are you need to just check a few things. You need to check their size and their orientation. Orientation as in how do they look? So if it's the same size, so we know it's not an enlargement. So here they are the same size, because if you just look at the side lens, 3 and 3 there, cool. And they are the same orientation. So we know it's not a rotation. So we know the only thing it could be is a translation. So describe fully the single transformation that maps shape S onto shape T. So we need to go the correct way. We are going from this shape here up here. So the transformation we know is a translation. And we need to say by how much. So we pick a point on S from here and then pick the same point on T. Here it's at 1, -3, and we're moving it to -4, 3. So that is basically going 5 units left, and we're going 6 units up. So the vector is -5, 6. So it's a translation of -5, 6. This is year 11 content. It's higher paper. Yep, thank you for helping everyone out in the chat. I appreciate it. So yeah, this is the answer, translation by a vector of -5, 6, because remember the top is the x part and the bottom is the y part. If it's negative, then that means left, and if it's negative on the bottom, that means down, and if it's positive, it means right and up correspondingly. Okay, so nice little translations transformation question. Not too bad so far. Part 3 is about error intervals. So the length of a football pitch is 90 meters. Correct to the nearest meter. Complete the error interval for the length of the football pitch. So the way I like to do these is I look at how much has been rounded to. Here is the nearest meter. So nearest meter is basically to the nearest 1 meter. What I do is I take, would this not be a rotation? This is not a rotation because here, I mean, is not, because if you rotate it, imagine this shape, it is going to be turned around. The shape S, if you brought it up here, it would probably be something like this orientation. So that's why it's a translation, because the orientation is still the same. Okay, so what I do is, with error interval type questions, no worries, Yasmin, is you take the precision you rounded to. So here I've rounded to the nearest 1 meter, that's my precision, and I half it. So I have 0.5 meters. And all I have to do is take the value of rounded to, which is 90, and do plus and minus half of that precision, 0.5. So 90 minus 0.5 is 89.5 meters, and 90 plus 0.5 is 90.5 meters. And that is my error interval. That's all you have to do, exactly. You have to do the half of the precision or the resolution, whatever word you want to use, and then do plus minus that to find the error interval. And you can check, okay, if I round 89.5, it will round up to 90 because 5 rounds up. And if I round 90.5 but it's less than that, so like 90.49, I'm going to round down, and it'll round down to 90. So this is indeed my error interval. And that's how those type of error interval questions go. Not too bad, nice little 2 marks there. Hopefully you guys remember that trick and use the correct resolutions and have that. Okay, cool. So far, if you were saying this paper, hopefully you'd be happy, like with this introduction. I mean, I was happy when I sat this for my GCSEs. And then question 4 is a nice little 4 markers. It's not as bad as it looks, just a lot of words. So we're going to turn those words into numbers. Festival A will be in a rectangular field with an area of 80,000 meters squared. The greatest number of people allowed to attend Festival A is 425. So the area of A is 80,000 meters squared, and then the number of people is 425. See, I've just written down this is higher, just written down the numbers from the text. Festival B will be in a rectangular field of 700 by 2,000 meters, so I just need to find the area of B, which is not bad. I just have to do 700 times 2,000, and I get 1, 4, and then how many zeros? 5 zeros. So that's 1, 2, 3, 4, 5. That is 1,400,000 meters squared. And then the number of people allowed to attend is 6,750, so 6,750 people. The area per person for Festival B is greater than the area per person for Festival A. We need to find out how much greater. So we need the area per person. If you do a per thing like this, that means divide. So the area per person of A is going to be equal to 80,000 divided by 425. I put that into my calculator. I get 123 divided by 425. I get 188.3235 blah 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 meters squared. Then the area per person for B, I do exactly the same thing. It is 1,400,000 this time, divided by 6,750, and I get 207.407, and those are recurring. So we need the area, we need to find how much greater this area per person is compared to this. So all I have to do is B minus A, so that's 207.407, blah, 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 minus 188.235, blah, blah, blah. And that gives me 19 meters squared to the nearest integer, because they asked me to the nearest whole number. And that's my answer. So nice little like word problem there. Let me just see. I don't have time to go through IGCSE Edexcel questions, sorry, but this is GCSE. Most of the stuff applies to IGCSE, but IGCSE just has some more stuff. If you stay on this live, you won't be cooked, don't worry. I hope so, at least, anyway. Loci and constructions, if it's in the spec, revise it. Whatever's in the spec, revise that. This is only question 4. It's not bad. Like, if, as you've seen, I've just written it down, and hopefully that made it a lot easier to understand. This is Edexcel. Why would someone choose to go through this pain? Well, I enjoy maths, so I choose to endure the pain, guys. Okay, cool. Part B, they always like this sort of question where you have to prove someone wrong. They always have someone saying something wrong in a maths paper, and then you just have to say why they're wrong. So call them out. Callum says 300 centimeters squared is the same as 3 meters squared because there are 100 centimeters and 1 meter, so you divide by 100. All of you should be able to clearly see why that is quite blatantly wrong. So what you have to do is, what I'd recommend is say why he's wrong, and then also state what the correct thing should be, just so you know if you say one of those things incorrectly, your other thing could be correct, and then you may get the mark for that, potentially, depending on the mark scheme. So what I would write here is I'm going to write shorthand, but you write the full sentence. When you convert areas in centimeters squared to areas in meters squared, you divide by 100 squared because that's the area scale factor. So you do 300 divided by 100 squared equals 0.03 meters squared. Since we are converting area scale factors, not length. Because if it was length, then you just divide by 100. So you write the correct answer. That's my tip. Hey, nice. Well done for getting a 9 on this paper. Okay. Come on, guys. Let's all try and get 9s in this exam tomorrow. Okie dokie. For part 5, for question 5, the points L, M, and N are such that L, M, N is a straight line. The coordinates of L are -3, 1, M are 4 and 9, and then we're given a ratio of L to M, then M to N is 2 to 3, and we need to find the coordinates of N. Whenever you have these types of questions, thank you for the gifts, guys. Whenever you have these sorts of questions, always just draw it out. Whenever you have coordinates, just draw it out so you can easily visualize what is actually happening. So they tell me LMN is a straight line. So with a ruler, I will draw my straight line. And we know that L to M is 2 parts and M to N is 3 parts. So this is going to be a little bit smaller. So that's L, that's M, and then that's N. Doesn't matter if it's accurate or not. So this is going to be 2/5 of my line and 3/5, because remember, ratios is about like the total. And then I got GCSE maths paper 2 higher. I'm watching A-level stuff. No, this is a GCSE stuff. Don't worry. A-level stuff is later. So now I will just write down my coordinates. So that's -3, 1, and then M is 4, 9. And I need to figure out what N is. So X, Y. Okay, cool. So what I like to do is I like to just do it the simple way, the old-fashioned way, where I'll just step up. You can find the gradient and do it that method, find equations of lines, but I like to just do, I don't want to overcomplicate it. So I just keep it simple because it's like using a coordinate grid. Said Yusuf. So for 2 parts, we know that this section here is 2 parts. So 2 parts is 7 across to the right, and because you're going from -3 to 4, and then from 1 to 9, that's 8 up. The calculation is 4 minus -3 equals 7. And then 9 minus 1 equals 8. Those are the things you would write down in the calculations. So I want to find out what 1 part is, so I just divide by 2. So 1 part is 7 divided by 2 is 3.5 to the right, and 8 divided by 2 is 4 up. Now I know that from M to N is 3 parts of this ratio, so I'm going to multiply by 3 to get 3 parts. So 3.5 times 3, 3.5 times by 3 is 9, 10.5, and then 4 times 3 is 12. So 12 up and 10.5 to the right. Now I need to make sure I go from the correct coordinate. So that's 3 parts from M over here, right? Because that is 3/5 on this side. I could have found 5 parts and went all the way from L. I will get the same answer. So from M equals 4, 9, you go 10.5 to the right and you go 12 up. So 4 plus 10.5 equals 14.5. And then 9 plus 12 to go up equals 21. So your N coordinate, therefore N is going to be equal to 14.5 and 21 as your final answer. for a nice little 4-marker coordinates question. So it's 4 marks, but we didn't actually do any complex working. We just imagined we had a coordinate grid and just worked it like that. So don't overcomplicate it. When I sat this question in the exam, I was tempted to overcomplicate it, but I was like, no, just keep it simple. The simple way will work, but just make sure you write down enough working. So quick explanation again, draw out the picture of your straight line like I've done here. And we know that going from here, L to M is 2 parts of my line. So I could just find how much going 1 part of my line is. So for 2 parts is 7 across and 8 up, from -3 to 4 and from 1 to 9. Find 1 part is by dividing those by 2. And then I need to find 3 parts because I want to go from M to N. So just multiply those by 3 to get my 3 parts. It's all about proportionality. Then I need to add my 3 parts to my N coordinates. So from 4, I do 4 plus 10.5 to get 14.5. Then from 9, I need to go 12 up. So that's 9 plus 12 is 21. That's how you do this sort of question. This is the 2022 paper 2. It's the paper I sat in my GCSEs, so it's fun going through it with you guys. Okay, a new phone costs £679. The value of the phone decreases at a rate of 4% per year. So if it's decreasing at a rate of 4% per year, my multiplier is going to be multiplied by 0.96, because the original amount would be multiplying by 1, but I'm having 96%, which is 4% off 100%. So I multiply by 0.96, which is 96% as a decimal. So that is my multiplier. Work out the value of the phone at the end of 3 years. So we know it's initially £679. So after the first year, it is 0.96 of its original value. So after 3 years, you basically do that times by 0.96, times by 0.96, times by 0.96. So you're just multiplying it by 0.96 cubed, 1 for each year. When you put that into your calculator, you get 679 times 0.96 cubed. I get 600.73574 blah blah blah, and because it's money, we have to round to 2 decimal places. That's 74 to 2 dp, and that's my answer, 600.74. Hopefully exactly it works, kind of like compound interest with the multiplier going off the previous amount. Yep, you can just cube it, which is what we did. Perfect. Okay, question 7 is the first slightly long question. There are many ways you can go about doing this. I'm going to show you the way I went about doing it in my exam. It is a slightly longer way, but it's more thorough, and you can see how it works in different cases. So, nice little conversions question, very useful if you want to go on holidays. So, not too difficult, in my opinion. So, in Spain, Sam pays 27 euros for 18 liters of petrol. So, I like to write this down. So, Spain, we pay 27 euros for 18 liters. And in Wales, Leo pays £40.80 for 8 gallons of the same type of petrol. So Wales is 40.80 equals 8 gallons. Just put G, doesn't really matter. So we know that these are my conversion rates for euros to pounds and from liters to gallons. Sam thinks petrol is cheaper in Spain than Wales. Is Sam correct? So to compare these, we need to have them all in one common currency and one common metric, like liters or gallons. So I'm going to let's find the price in, let's go for pounds, of 1 gallon. You can find a middle ground. You don't have to do both conversions, but I'm doing this just to show you the full way of showing you twice how to work this through. So we have 4.5 liters equals 1 gallon. So to go from liters to gallons, I divide by 4.5. So if I'm going from 18 liters in Spain, 18 liters equals, I'm going to divide that by 4.5. And I can do 18 divided by 4.5, that gives me 4 gallons. So we know that in Spain, 27 euros is equivalent to 4 gallons. Now I'm going to divide that by 4 to find out for 1 gallon, because that's what we want. So 27 divided by 4 is 6.75 euros equals 1 gallon. Okay, now I need to go from euros into pounds. So to go from 1 euro into pounds, I multiply by 0.85. So I'm just going to do 6.75 times 0.85. And if I do that, I get in pounds 5.7375. So in Spain, it's 5.74 for 1 gallon. Now I just do the same for Wales, but for Wales it's significantly easier because I have 40 pounds 80 is for 8 gallons. So if I divide through by 8, I get 5 pounds 10p for 1 gallon. So in Wales, it's this much for 1 gallon, and it's in Spain is this much for 1 gallon. So I have my prices for the same amount. Now I just need to compare according to what Sam says. So Sam thinks it's cheaper in Spain than Wales. So is 74p smaller than 10p? Nope. So we just say, therefore, no. Sam is wrong. We're calling out someone again, and we're only on question 7 of the paper. And we need to state why. Because £5.74 in Spain is greater than 5 pounds and 10p in Wales for 1 gallon of petrol. You can also say other things like it costs 64p more in Spain than in Wales for 1 gallon of petrol, other ways of comparisons. So that's the full question and that's the full answer. So you can see how I've worked that through. I have my 2 separate columns side by side, laid it out quite clearly, showed my conversions and my steps. I worked it through one thing at a time. This is money conversions. I don't know, I forgot the exact name, but I know it's like exchange rates. Yeah, exchange rates. So exchange rates is like a subtopic of like proportionality. So if you know how to work with proportions, you'll know how to work with exchange rates. It's always following the same rule that I explained. So I'll just explain it one more time from a high-level overview for unknown T. This is Edexcel. So I write out my facts from the paragraph there for Spain. For Spain is 27 euros for 18 liters. For Wales is this much. And I need to compare the price for petrol in Spain and in Wales. So I'm going to convert them to the same currency and in the same metric, so gallons and pounds, so I can easily compare them equally. So first converting 27 euros and 18 liters into pounds and gallons. So I converted my liters into gallons by dividing by 4.5. And then I converted my euros into pounds by multiplying by 0.85. And then I found that for Spain. Then I have this much for gallons in Wales. I need for 1 gallon, so I divide by 8. Then I have my 2 final prices, and then I just compare them in relation to the statement at the top. Okay, nice. The beginning is easy, the end always gets me. So make sure you can bank all the marks at the beginning, Ruzish. Try and like confirm all of them just so you know we're better off when we get towards the end. Awesome, guys. Question 8. If you guys get a question like question 8, you should be super duper happy. It is a free 2 marks. All you need to know is how to use a calculator. So make sure you know how to use a calculator. So I'll zoom in on this one. The live is recorded KDO. I'm going to put it up on my YouTube channel as soon as I can after the live stream. So I'm going to show you what to do, and we need to answer this to 3 significant figures. So I'll just underline that and put 3SF here so I don't forget. So what you do is in your calculator, I'll show you, my bad, drop something, how to type it. So I do my fraction first, and then on top they want the cube root of something. So you go on to this button here, which has the little square over the root sign, and I put my 3 over there. And then in my root, I've got 1.57 to the power of 4. So 1.57 to the power of, using this simple, 4 plus tan 60, and it's in degrees. If your calculator is in radians, which it shouldn't be because GCSE doesn't have that, make sure you convert it to degrees. So far that matches. And then I go out and then make sure my cursor is on the bottom part, and I do 7.2 to the power of a half. And then just check what's on my calculator does match what's there. Make sure your powers are in the right place. That's the only annoying bit, powers. And then you get your answer of 0.739333. So I will write that out. Obviously, you don't need to write this out again. Just write equals 0.739333 blah blah blah. Write down more significant figures than required initially in case you get a rounding error, so you could potentially maybe get 1 mark, and then you round 0.739 to 3 significant figures. Because I look at my third sig fig, look at the value to the right, 3 is less than 5, so I round down 0.739 for a nice little 2 marks. I'm not 100% sure if this comes up in a foundation. If someone who does foundation has seen this before, feel free to confirm. I don't see why not, because it's just using a calculator. But in my opinion, very nice, free marks. I hope you guys get this question in your exam tomorrow. Okay, question 9. You guys just had your physics paper today, I believe. Correct me if I'm wrong. So this one is basically a physics question. It's not hard, and they even give you the pressure formula. So pressure is force divided by area. So reading the question, a box in the shape of a cuboid is placed on a floor. How thrilling. The box exerts a force of 180 newtons. So what I do is I write the symbol representing that value near the number F. The box exerts a pressure of 187.5 newtons per meter squared on the floor, so that's my symbol P. The face in contact with the floor is a rectangle of length 1.2 meters and width x meters. I never want to see pressure again. This is not bad though. This question is nice, trust me. Work out the value of x. So using our formula, P equals F over A, we know that P is 187.5 and F is 180 and A is my area. We know that the length is 1.2 and the width is X. So if I just show you like this is what the base of my little box looks like on the floor. So we know that the area is 1.2x. So if I'm solving for x, let me rearrange. I'm going to multiply both sides by 1.2x and divide by 187.5 at the same time. So we get 1.2x is 180 divided by 187.5. And then I divide by 1.2, so that's 180 divided by 187.5 times by 1.2, because if you divide it, it goes on the bottom part of the fraction. Put that into my calculator, 180 divided by 187.5 times 1.2. I get a very nice answer of 0.8. So x is 0.8. The unit is meters, but they just tell us what's the value of x. So that is the answer to this question. 3 marks, in my opinion, not so bad. I hope you guys didn't find this one too bad too. Similar questions could come up where it's just a bit of missing algebra. Just make sure if you struggle with visualizing it, do a little picture like I did here, 1.2 times x, and then you continue from there. How is this going so far? Is anyone thinking in the chat? Okay, cool. Glad it's making sense. Question 10. It's our little statistics question, our box plots one. What do you guys think of box plots? Let me know in the comments. So the box plot shows information about sales in thousands of pounds for an online store each month. So these are my sales. Andrew says this is higher, yes. Andrew says 3/4 of the given data lies between 160,000 and 350,000 because these are the values of the lower quartile and upper quartile. I like to write the letters there for reference. Straight up, Andrew is wrong. Andrew, give me a break. So, Andrew is wrong. Explain why. This one should be quite obvious. You got a question on interpreting box plots in paper 1? Okay, I will go through this one quickly then. The interquartile range is half the data. That's all you need to say pretty much. So, half the data lies between 160,000 and 350,000. Because we know that the difference from upper quartile to lower quartile is the interquartile range. Can I go back? I'll just quickly show this question. Take a screenshot if you want. Then I'm going to scroll down in 2 seconds. 1, 2. Okay, cool. So yeah, with these ones, just make sure you know what each of these lines means. This is the least. This is the lower quartile. This is the median. This is the upper quartile. And this is the max. And then this is the interquartile range, and then this is the range. So that's how you read a box plot. Quite nice. Okay. Then we have to draw a box plot. This table shows information about sales in a shop each month. So the difference here is this is an online store and this is a shop. They were very, very subtle with that in this question. So just make sure you read it properly and know what the difference is. The least value is 30, so just make sure your increments are correct. I'm going to do this as best as I can. So the least value is 30, so it'll be there. The lower quartile is 80, so then that will be there. Use a ruler, obviously. Then the median is 170, so then that's here. upper quartile is 260, and then the greatest value is 350. And then I just do my lines going there, and then on the top, and then on the bottom. And there's my little box plot. Very nice. Then you compare the distribution of sales of the online store with the distribution of sales in the shop. That's the difference between these two ones. What are they actually showing? So when you compare the distribution, you compare two things. You compare the median average, and you compare the spread. And when you compare the spread, you've got two options. You either compare the range or you compare the IQR, the interquartile range. So what I would say is, I'm not going to write it down, but I'm going to say it slowly. So actually, you know what, I'll write it down. So on average, the median and then I need to compare the values. So I need to find which one has the greater median. So the median on the online store is 200,000 and the median in the shop is 170,000. So the median in online store of 200, I'm just writing K, is greater than, and you need to have the comparison because they want you to compare. It's greater than, that is a terrible line, the median for the shop, which is of 170K by 30K. That's the difference. Then for the second comparison point, because it's 2 marks, we need to compare the spread. So if I look at the range, I will compare the interquartile range. So the IQR here is 190K for online, and in my shop it is from here to here, so that is 180K because that's 260 minus 80. So then I'll say online is more spread out. So the sales data online is more spread out than in the shop. And then you have to state the values because, and then online, the IQR is equal to 190,000 and the shop, the interquartile range is equal to 180,000. If you did the ranges would be 360K online and 320K in the shop. And that's how you do this type of question for a comparison of the box plots. We got in paper 1, so could it come again in paper 2? If you got in paper 1, it's very unlikely it'll come again in paper 2, but it could be there in a different way. You could have it in a comparison type question. It's not impossible, they can do whatever they want, but it's unlikely that they would want to assess it again. I just went through it for completeness sake. Okay, cool. Kieran has 13 workers he can use for a job. He knows that 6 workers take 14.5 days. Show that Kieran has enough workers to finish the job in less than 7 days. I think you guys got a similar question to this as well. This is a higher paper. This question may appear in foundation. I'm not 100% sure about proportionality, but this is about inverse proportionality. So quite simply, 6 workers take 14.5 days. So I'm going to find out how long one worker takes. So if I divide by 6 for my workers, I multiply by 6 here because inverse proportion, as the number of workers decreases, the time taken increases. So 14.5 times 6 is 87 days. And if he has 13 workers, we will multiply that by 13. So 13 workers is equal to 87 times 13, divided by 13, because inverse proportionality is 6.69 days to 3 significant figures. And is that enough to show that it's in less than 7 days? Yes. Then we just say 6.69 is less than 7 days. Therefore, he has enough workers, imagine that says workers, to finish the job in less than 7 days. And that's it. Nice little inverse proportion question. Very nice. Question 12. Question 12, when I got this, I was pretty happy when and I saw this in my paper. It's a very standard paper as long as you know how to work with the equation of a straight line. So the equation of a straight line is y equals mx plus c or plus b, whatever you want to say. So we know that L1, y equals 2x plus 3. Oh my god, I forgot to read the question. So we're given the equations of lines L1 here and then L2 here, and we need to show that they're parallel. And if they're parallel, they have the same m. They have the same gradient. So exactly, you rearrange Izzy. So for number 1, we don't need to rearrange. We just know that m is equal to 2 here. For L2, we need to rearrange 5y minus 10x plus 4 equals 0 into a y equals mx plus c form, so we can actually read off the gradient. So I'm going to, well, what happened there? So I'm going to do 5y equals 10x minus 4, bring all of my non-y terms onto my right side. Then I'm going to divide through by 5. So 5 equals 2x minus 4 over 5. And then I can see my gradient is 2. So then I need my conclusion. Therefore, both have the same gradient of 2. Therefore, they are parallel. You need to connect that fact to the fact that they are both parallel. Nice little 2 markers there. Shouldn't hopefully take you too long. And then question 13 is the inverse of what we did in my first GCSE live of this exam season 2 days back. So here we need to enlarge the shaded shape by a scale factor of -2 with a center of enlargement 0, 0. So here we're just doing backwards what I said to do before. So my center of enlargement is here, 0, 0. And I'm going to do this in blue just so it's easier to see. So I know that I'm enlarging it, so the sides are going to get bigger, and also the distance from this point is going to be bigger. However, it's also going to be in the opposite direction. Negative means opposite direction. So here I'm going 1, 2 down and 1, 2, 3 across to get to this point. So I'm going to go 4 up here, and I'm going to go 6 across here. So that is my first point. Then I know that this one is going to be the same amount up, but it's going to be 4 across because the side length will double since it's a scale factor of -2. And then I'm just going to do this point down here to be safe. So I'm going 1, 2, 3, 4 down, and then 1, 2 across. So I'm going to go 8 up, and then 4 across. 1, 2, 3, 4. There. My diagonal gap was a 1 unit across, and now my diagonal gap is 2 units across, which is good. And then I know that this had a length of 4, so now it's going to have a length of 8. That's 2, 4, 6, 8. So it goes there. That is my new shape. Now all I have to do is join my sides, just like that. And then that I don't need to annotate it, but then that is my final answer. This is Edexcel, yes. So very nice little question here, and I can just check that this side length is 4, and this side length is, it used to be 4 there, so it should be 8. So 1, 2, 3, 4, 5, 6, 7, 8. Cool. And the height, it used to be 2 and now is 4. So it has a scale factor of 2 and is negative, so it goes in the opposite direction. Okay, cool. That's how you do negative enlargements for transformations. Question 14 is a capture-recapture. I've not seen this a lot in the past. All I know is that I had to put up with it. It's a very random topic in my opinion. So for this one, question 14, Saffron wants to work out an estimate for the total number of fish in a lake. On Friday, Saffron catches 180 fish. She puts a tag on each of these fish and puts them back into the lake. Sounds like abuse to me. On Saturday, Saffron catches 305 of these fish from the same lake. She finds that 45 of the 305 are tagged. Work out an estimate for the total number of fish in the lake. Can I repeat the enlargement, I'm assuming. I will repeat the enlargement after I do question 14s. Melina, this is capture-recapture. It's a statistical topic. It's a very random one in my opinion, because I don't even think this comes up at A-levels. I'm not 100% sure, but I don't remember explicitly doing this at A-levels. Okay, so the trick is just deal with these as fractions. It's a very mechanical, methodical approach. So she catches 180 fish on Friday. So on Friday, she catches 180 and tags them out of, and I need to figure out how many total fish are in the lake. I'm just going to call my total fish N. Then on Saturday, she catches 305 and finds that 45 are tagged. So just make that as a fraction. Now I'm going to assume that the number of tagged fish remain constant and that the proportions are the same. So all I can do is these fractions, because a fraction is like a proportion, like a ratio, 180 over n is equal to 45 over 305. And all I have to do is solve for n. This is Edexcel exam board. So all I need to do is solve for n. So n is going to be equal to 180 times by 305 divided by 45. I want to do that, get 1,220 fish. 1220 fish. Oh, SH. My bad. And that is how you do a capture-recapture question. It is very standard. Just put the fractions, give your total an unknown number, and then just solve for that. So if they ask you about assumptions, here are some things you could say, because that could be a part B of a question like this. You could say that the tags remain intact on the fish, as in the fish don't lose their tags. No fish die or are born in that time period, because you want to estimate the total number of fish in the sake between using information from Friday and Saturday. And you could say like i.e. the values or the proportions stay the same. So that's how you do it. Pretty set. This is the method. So what I did, and that's how you get the marks. This is the enlargement scale factor question. So what I do is I start in my center of enlargement. I see how am I going to get from that point to one of the points on my original shape. And then I have to go in the opposite direction because it's negative. So if I go 2 down and 3 left here, I'm going to go 4 up and 6 right here for that point. I do the same for all of my other points, but I can use shortcuts in the fact that I know that this is a length of 2, and then it's going to be in the 2 to the left. So this is going to be 4 to the right. So I know that that's my other point. And then just do the others, and then boom, I have built my little shape. Okay. So that is question 14 done. We've got, I think we're doing very good for time. We've got 50 minutes left to finish this before I have to do an A-level paper. It's going to be a long night. But yeah, that's question 14. And this is Edexcel. Yep, as Dexter says. Thank you, Dexter. Okay. Question 15. Not the nicest ratio question, in my opinion. I'm not a huge fan of ratio type questions. So with them, I like to write out a lot of information to fully understand it before jumping into it. So the ratio of Martha's hourly pay to Khalid's hourly pay is 6 to 5. So I like to write that out. M to K is 6 to 5. Both Martha and Khalid get an increase of £1.50 in their hourly pay. The ratio of Martha's hourly pay to Khalid's after this increase is 13 to 11. So M to K is now 13 to 11. Makes sense that Martha still has a higher proportion of that ratio to Khalid because she started off with it higher. Work out the hourly pay before the increase for both Martha and Khalid. So the main thing you need to remember about ratios, and I'm going to write this down, is ratios are simplified or can be simplified. So ratios can be simplified. So 6 to 5 as values are 6x to 5x. Because remember, when you have a ratio, you simplify. This is not a nice paper. Parveen says, no, this is not too bad of a paper in my opinion, well, at least from how I found it. So this is what you need to remember, because if you have a ratio like, I'm going to give you an example, 6 to 4, you can simplify this ratio by dividing both sides through by 2. So that would be 3 to 2. So this is basically 3x and 2x, where x is equal to 2. This is the idea of a ratio, and I'm using that idea up here because I need to find the original non-simplified value. So can I redo? Yeah, I just started this question, so I'll just say we know that the ratio is 6 to 5. So as values, that's going to be 6x to 5x. So before, like I said, I like to write everything out with a ratio question. We have 6x to 5x, and then after, they're going to get an increase of £1.50. It's not a multiplication, it's an addition increase. So we have 6x plus 1.5, and that is not x because that is a definite value of £1.50. It's not a scaled version of £1.50, hence we don't multiply by x. To 5x plus 1.5, and we know that that is going to give me 13 to 11 because that is the ratio after this increase. So all I have to do is remember that ratio means divide. Ratio means divide. So 6x plus 1.5 to 5x plus 1.5 is basically the same as saying this. 5x plus 1.5. And then that. That's all it is because ratios are division. So then I'm just going to cross multiply by 11 and by 5x plus 1.5 and then just solve for x. So I have 66x plus 11 times 1.5 is 16.5 equals 65x plus 19.5. Then I'm going to subtract 65x from both sides, so I get x is going to be equal to 3. Very nice answer for x. Am I done yet? No. What do I need to actually do? Look at the question again. The hourly pay before the increase for Marta and Khalid. Well, I know that Marta was 6x, so x was my scale factor, which I simplified by. So 6 times 3 is 18, so she was paid 18 pounds. And Khalid was 5x, so 5 times 3 is 15. And we can check that as a ratio, and then simplify by dividing by 3, and we get 6 to 5. And that is how you do this question. Hopefully my little explanation made sense, made it not as daunting, because all you need to do is just remember the key facts about how ratios work. Ratios mean divide, and then ratios can be simplified. So logicking it through that way. Sometimes it also helps to draw out the box picture. For this one, I didn't feel as much. I think in my actual exam, I attempted drawing that little box, but I don't see why you would need that here. But yeah. Check the comments to scroll up a bit. This is, I'd say it's like a middle to higher end grade type question. What do I predict the grade 5 will be? I think it's a bit too early. Like paper 1, from the way I looked at it, purely objectively saying, I think it was a nicer paper 1. So they could be similar to last year's grade boundaries, in my opinion. This is GCSEs, so if there's ratios, use X. That's what I did for this question, because the ratio is simplified, so it's scaled version by a scale factor of X, so I used X in this one. This is GCSE. I'm going to finish this paper by 7 ABZ. Do I feel nostalgic? Yes, this is very nostalgic. So if there's two ratios, you do 6x and 5x. Well, I don't get what you mean by two ratios, because if you have a ratio of 6 to 5, or any ratio, even like 14 to 10, I can simplify that to 7 to 5, and we know that I can write this as 7x to 5x, where x is equal to 2, because then that'll get me back to this. That's how ratios work. It's simplified. What grade did you get? I got a 9. I'm going to do A levels from 7 to 8:30, potentially 9, Zaki. Okay, cool. Oh, my bad. Oh yeah, that's the timings for reference. Okay, I'm going to move on to question 16. This live is recorded. I'm going to try and get all 3 of my live stream videos up tonight after the lives. They do take time to export, so at least the first GCSE live I did will be up on my YouTube hopefully soon. Okay, cool. This is a higher paper. So, triple Venn diagram question. I'm not sure, did it come up in your paper 1? Let me know in the chat, please, if it came up. But in my opinion, these are pretty fun. They're like a little puzzle. You just need to remember the little nuances and read each sentence very carefully. It didn't come up? Okay, cool. Let's go through this all together. So, a shop manager wants to advertise special offers on social media platforms. They ask 100 customers, so that's my total, which type, A, B, or C, they use. What thrilling names for these social media platforms. Of these customers, and then I like to just read all of this information first, and then I read through them again, and I put them into my chat. Thank you for the rose, Juna. Okay, so 4 use all 3, 16 do not use any of A, B, or C, 8 use A and B but not C, 14 use B and C. So note the difference here and here. They're saying not C here, but they're not saying not A here. So that's a little nuance we need to look out for. 62 in total use A, so in my whole A circle is 62. All 20 who use type C also use at least one of type A and B, so I know that this is going to be 0. There's no one who solely uses C. And then they don't give me information about one of these, and I'm going to have to calculate that using my total, because that's what's stated at the top. Cool. So now that we've read through it, I'm going to show you exactly what I would do to work my way through it and how to interpret each sentence, and hopefully you'll understand it by the end. So 4 use all 3. So 4 goes in the center because they're in A and B and C. So that is done. 16 do not use A, so I'm not in this circle here. Do not use B, so I'm not in this circle here, and do not use C, so I'm not in this circle here. Where is my spot remaining? It is outside, so outside it, I'm going to put 16. That's my next part. 8 use both A and B, but not C. So A and B is this section here. I'm going to do it in blue, actually. So this is A and B. And this is where the nuance is. But they're saying, but not C. So it's not this section here. So the only bit left of my diagram is this top bit up here. So that is where I put 8, because 8 use A and B and not C. Let's rub this out. Okay, hopefully that's making sense so far. Now this is where most people make mistakes on this type of sentence. 14 use both type B and type C. So whereas type B here, this is my type B circle, and type C is here. I need the intersection of B and C. So again in blue, that is this whole thing here. Because if you remember, a Venn diagram is like this. So BC, this is B and C. So in that whole overlap oval type shape, we have 14. But so far, we already have 4 there. So we know that this part here is going to be 10, because that's 14 minus 4 equals 10. So overall, we can see in this oval section here, we get 14, and that's the trick which you need to look out for. So highlight the sections of your Venn diagram, and then make sure the totals are what they say they are in the question. Hopefully that makes sense. That's the only hard part of these Venn diagram questions. Others are quite intuitive. 62 in total use type A. So I know that this plus this plus this plus this add up to 62. Well, I'm missing 2 boxes there, so let me see if I can fill in something else before I do that. Let me just save this. All 20 who use type C, so I know that in my C circle, that's going to be 20, also use at least one of type A and type B. So we know that no one uses just C. And then we know that in this whole circle, they need to add up to 20, exactly following the same logic as we did for this one over here. So 20 minus 14 is 6. So that goes 6. And now we can go back to our 62 in total use A. So for A, that's going to be 62 minus 8 minus 4 minus 6 minus 8 minus 4 minus 6. And I get 10, 14, 44 over this for A. Now, have I completed my Venn diagram? Nope, because this section here is still missing. They are typically not going to give you one more fact explicitly for that, but you need to use the fact they give you at the top over here, which I underline, of 100 customers. So we have 100 customers. We know that 62 use A, so take away 62 from this. Then we just take away 10, and we take away 16, and then we get 12. So 12 just use B, and that is it for 4 marks. Let me just check. Hopefully, does that explanation make sense to you guys? Just about circling the sections on your Venn diagram makes it much easier. Hopefully that explains it. Hey, I'm glad it makes sense now, right, hon? Hopefully this does come up tomorrow. It's not bad. It is just about logicking it through. Perfect. I'm glad it makes sense to everyone. I'm happy. Good. Success. Okay, cool. Part B. One of the customers is chosen at random. Given that, whenever you see this phrase here, given that, you need to restrict your view. So given that, they use type A. So ignore the rest of this entire diagram. Ignore all of this. You're literally just looking at this circle here whenever you have a given that. Find the probability that this customer also uses type B. So also B given A. So given A, how many people use A? We have 44 plus 8 plus 4 plus 6. Well, they actually told me that it was 62. So 62. And they also use B. So I'm looking at this circle here. Which parts of this circle are also in my B circle? It's just these bits here. So that's 8 plus 4 equals 12. So then that's literally just 12 out of 62. Because remember, restricted to A, and that is also use B. So that's like B and A. So therefore, we have 12 out of 62 as my probability. You can simplify it if you want. They say or equivalent. I tend to not for probabilities. Awesome. 100 is a set total. Everything adds to 100. So yeah, this one is because we have 100 customers. If it was like 200 customers, then all of these numbers have to add up to 200. So they'll tell you the total if you need to use that to figure it out. Fez. And then, can I explain the symbols like union? Yep, sure. So the symbols you need to use for sets. So this is set algebra. You've got union, intersection, and complement. So union is like A, U, B. So it's anything in A, and including anything in B. A and B is the intersection. So that's a terribly drawn circle. Then that is this part here. Here is literally everything in the circle. And then here, if it's like not A. So this is my Venn diagram. It's like everything not in it. So the complement of A. Those are the three symbols for set notation. Okay, cool. Sets question, Venn diagram question, very nice in my opinion. I was happy when I saw this. I hope you guys will be too after that explanation. Again, thank you for the roses, guys. I appreciate all the likes and the support. Okay, that is question 16. Doing very good for time. We are almost there actually. So hopefully you can see how fast we're going through this and the fact that I'm waffling so much about each question. Like it shows, oh my god, 9 roses. Thank you so much. So you can see that hopefully, if you take it through, say the things in your head as you're walking through the questions, like I'm doing out loud, then you should be fine in the exam, hopefully. 1 second, I just gotta verify I'm still here. Okay, cool. They're making me drag puzzle pieces on the screen. Okay, awesome. Isn't the 8 supposed to be a 4? Where is the 8? Nope, this is the thing. I checked my answers beforehand, don't worry, so I made sure I'm not making any mistakes. But yeah, this is the mark scheme here. Okay, cool. Moving on. Question 17. When I see a cones question, like every time I see a cone type question, I sigh. I hate these questions, but they're not bad. They're just disgustingly long. I don't like geometry in my opinion. That's me. I hate geometry out of all sections of math. So, but this question is not bad. It's just an upside down ice cream cone. A solid cone is joined to a solid hemisphere to make the solid T shown below. So T is my whole thing here. They're giving me the formulas for volume of sphere and a volume of cone right here. The diameter of the base of the cone is 7 centimeters. So that's diameter, not radius. So R is equal to 3.5 centimeters. Don't confuse your radius and your diameter. That is a very simple screw up. Don't screw that up. The diameter of the hemisphere is 7 centimeters. Shocker, because look at how they're drawn. The total volume of T is 120 pi centimeters cubed. The total height of T is y centimeters, which they've very nicely annotated. Calculate the value of y, give your answer to 3 sig figs. So always write what they want over there in a circle. This is a higher tier question, and yeah, in my opinion, I don't think this could be a foundation. I'm not 100% sure though. But yes, you'll be fine, Melina. You're staying with this live. You're interacting. That's good. Okay. Would you find the volume of the sphere and then divide through by 2? Exactly. That's how you find the volume of the hemisphere. Correct, Adamantium. So that's what we're going to do first. The volume of the hemisphere. And lay out your work neatly so you don't get confused. So we know that the volume of the hemisphere is equal to 4 thirds pi r cubed and a half of that, as Adamantium says, and that's going to be equal to 4/6 pi r cubed. So the volume of my cone is VC is 1/3 pi r squared h. So far, I've literally just regurgitated what the formulas are, but I like to write it all down just in case, I get some basic method marks for that in case I mess up later. Just write down everything one by one, step at a time. You should be fine. So we know that the total volume is the volume of the hemisphere plus the volume of the cone. So 4/6 pi, and my radius is 3.5. So 3.5 cubed plus 1/3 pi times by my radius, which is 3.5 squared, times by h. Do I have my vertical height here? Nope. I know that this is my h. Do I know what this is? Well, I do, because this is my radius, 3.5. Because I'm going from the center of my circle to another edge. It's kind of like that part just dangling at the bottom there. So I know that that height is 3.5. So I'm set there. And we know that that is going to be equal to 120 pi. That's the fact they've given me, that the total volume T is 120 pi. So I need to find y. In order to find y, I need to find h, and then just add that onto 3.5. Simple as that. So I'm going to just put this into my calculator. I'm not going to put my pi in because I don't want to have any rounding errors in the middle. So 4/6 times 3.5 cubed gives me 343/12 pi. And then I put this into my calculator, and I get plus 49/12 pi h, and that's equal to 120 pi. I can cancel out my pi's. See, that's why I didn't put in my pi, so it makes it so much easier. And then I get 49/12 h equals 1097 over 12, and then I have h is equal to 1097 over 49 if I multiply by 12 and divide through by 49. Why am I doing 4/6? Because the volume of a sphere is 4/3 pi r cubed, but we have a hemisphere, which is half a sphere, so we have 4/6 pi r cubed. So all I did here was just a bit of algebraic rearranging. It's not anything too bad, so just make sure you know how to rearrange algebra and fractions to find what h is. So I found what h is now, and now I just need to find y. So I'm just going to do my working here. So y is equal to h plus 3.5. So in my calculator, I put 1097 divided by 49 plus 3.5. And that gives me 1097 divided by 49 plus 3.5. I put in a 0 there, 2537 by 98, and that is equal to 25.8877 blah blah blah. They wanted to 3 significant figures, so if I round that to 3 significant figures, I get 25.9 as my value of y. And that's the answer to this. So it's not so bad, it is just a little long. Let me just check. So why did I make it 4/6? Because they have given me the volume of a sphere here. And this is what a sphere looks like. But there I have a hemisphere, and they tell me it's a hemisphere. So the volume of a sphere is 4/3 pi r cubed. So the volume of a hemisphere is half of this. So 4/3 pi r cubed times by a half. So I do 3 times 2, which gives me 4/6 pi r cubed. Hopefully that makes sense why it's 4/6. And yes, 4/6 is smaller than 4/3. So I will explain this one more time for name. So the diameter is given, the volumes are given, and the height is needing to be found. So I just have to use the formulas and piece it together like a puzzle. So the volume of a hemisphere is 4/6 pi r cubed, which I just explained, and the volume of cone is 1/3 pi r squared h. I've literally just regurgitated what they put in this box here, but with the hemisphere instead of a sphere. Then I know that the total volume, I need to use the fact they've given me, is 120 pi, and that's found by adding the volumes of the hemisphere and the cone. So I've just added them, and I've substituted in my radius, r, which is 3.5, because my diameter is 7. So my radius is half of that, 3.5. So then I have just put that in and equated that to 120 pi. I have a pi in all of these terms, so I can just cancel out my pi's, and then I've just put this into my calculator to get 343 over 12 plus 49 over 12h. That h has not gone anywhere, and that's equal to 120. All I'm doing is just solving an equation in for h, so I will bring all of my non-h terms onto my right side. So I did 120 subtract 343 over 12 to get 1097 over 12 equals 49 over 12h. And then I have h, I have 12s on my denominator, so I can just ignore those because I multiply by 12 on both sides. Then I get h is equal to 1097 divided by 49. But that's not it yet. I need to find what y is, and I know that this is 3.5 because that's a radius, right? A hemisphere is a radius on all of those things. Like even this going this way is 3.5. So 3.5 plus my height of my cone, which I found, which was my missing height there. You can see the diagram. So h plus 3.5 is equal to 25.8877, blah, blah, blah. They went into 3 sig figs, so that's 25.9 to 3 significant figures. And that's how you do question 17. Hopefully that makes sense. This is a calculator paper, and it's for paper 2. Wouldn't it be 4/3 because it's half the sphere? No, it's 4/6 because the volume of a sphere is 4/3. So you need to multiply this by a half to get 4/6 because 3 times 2. You multiply the tops by the tops and the bottoms by the bottoms. Yep, paper 1 is non-calc, and that's done. We're doing calc work now. Okay, nice. Now for part B, this is where we got to use a bit of visualization and problem solving. The diameter of the base of the cone and the diameter of the hemisphere are both increased by the same amount. So this thing here is increased by the same amount there. So you can imagine that I'm squashing this, little ice cream is being squashed like that. Assuming the total volume does not change. Okay, so I've got total volume is constant. So that means indeed it is getting squished down, because if these get wider to have the same volume, this has got to get smaller. Explain the effect this would have on your answer to part A. Well, what is my answer to part A? It is the overall height, y. So all I need to do is just say the height overall would decrease. So my answer to part A, y would be smaller. Why? Because if it's the same volume and a greater diameter, it'd have to be shorter in order to make sure that it would be the same volume. Exactly, it would decrease, Izzy. Correct. Awesome. So nice little 1 marker at the end of a 4 marker for a total of 5 marks for question 17. It looks really obnoxious. I'm just looking at my screen and all the writing I've done, but trust me, it's not as bad as it looks. Okay? It just looks bad because I've done it in pen and I scribbled everywhere. Hopefully that makes sense to you all. But yeah. Okay, moving swiftly on. Question 18, 19, 20, 21, 22. Okay, got 24 minutes to get this done before the A-level people come in. Nice. Question 18. Question 18, in my opinion, is a very nice question. We have 2 triangles. Thanks for all the likes, guys. I appreciate it. We need to calculate the length of QS. So QS is here. So because I don't have right angle triangles, I will have 2 choices. I have the sine rule and I have the cosine rule. Or I have A equal to half AB sine C, but that's only if area is involved. I don't seem to have any areas here, so I don't need this one. So I have this and this as my choice. I need the answer to 3 significant figures. So again, I put that there in my little circle so I don't make a dumb mistake at the end. So I need to find x. So I've got a side and an angle. And I also have another angle, but I don't have this side. So I'm going to call this side y. Exactly. Use cosine rule for triangle PQR, 100%. So for y, I want to figure out what y is. So I've got 1 side length, 2 side lengths, and 3 side lengths, and the angle opposite one of them. Perfect. So I'm going to use cosine rule for y because I've got 3 lengths, 3 sides, and 1 angle opposite the side I want. So state your rule first. A squared equals b squared plus c squared minus 2bc cos a, and then just sub in. Y squared equals 9.4 squared plus 11 squared minus 2 times 9.4 times 11 cos of A, which is 27, cos of 27. So we get that that's equal to 25.0998508. That is my value of y squared. So I need to find out what y is. So y is going to be the square root of 25.09 blah blah blah. And putting that into my calculator, I get 25.09999. I get 5.009975129, and I'm going to store that in my calculator as A using my store button. So I have the exact value, so I don't use a rounded one, just in case I get a rounding error towards the end. So this is my value for y, so I'll just label this as 5 here for now, blah blah blah. Now I've got a side and an angle opposite, and a side and an angle opposite, so I can use the sine rule. Now you see why I said this was a nice question, because it's literally just like simple application of cosine rule followed by sine rule. Exactly, the Atari used the sine rule now. Why? Because I've got 2 sides and 2 angles, the corresponding angles. So I'm trying to figure out the side length, so let me put that on top to make it easier. So x over sine of the angle opposite it, which is 88, so sine of 88, equals y, which is 5.009 blah blah blah. A is what I put in my calculator, divided by the angle opposite it of sine, so sine of 41. So x is going to be equal to a sine of 88, where a is just my calculator button. This is what I'm putting into my calculator, divided by sine of 41. And I get 7.63181 and blah blah blah. And then I round that to 3 significant figures, as I've helpfully written and circled on my page, to get 7.63 centimeters to 3 significant figures. And that's my answer. Very nice little question. It is cosine and then sine. Awesome. Hopefully this is making sense. Wait, can you explain how do you rearrange the cosine rule? Yep, sure. So this is my cosine rule. Here, I don't actually need to rearrange it because I'm trying to find out what A or Y is in this case. So this gives me for the side length. If I wanted to find the angle, I could rearrange and then plug in, or I could just simply plug in and then figure it out by rearranging at the end. But if you did rearrange for the angle, I'm going to bring this onto my left side. So add 2bc cos A onto my left side, and I'm going to subtract a squared onto my right side. So I get 2bc cos A equals b squared plus c squared minus a squared. And I want cos A, so cos A equals b squared plus c squared minus a squared. And because I've multiplied here, I do the inverse, bc. So I need to divide that by 2bc. And that's how you rearrange that. Okay, nice. You guys aren't cooked. Don't worry, don't worry. How do you know when to use the cosine rule and sine rule? Exactly what I said here. You use the cosine rule if you've got 3 lengths and an angle involved in your question, and you use the sine rule if you've got 2 side lengths and 2 angles involved. That is your giveaway. Know these things. Make a note of that when you have a question like this. And you know you need to use those if you've got a non-right angled triangle. Hopefully that makes sense, everyone. No worries. ... Okay, awesome. Moving on swiftly to question 19. Question 19, functions. So this part A is a free mark. Thank you, Said. This is Edexcel, Alu. So g of 16, literally just plug it in, equals cube root of 2 times by 16 minus 5. Put that into your calculator, you get 3. 1 mark in the bag, move on. Melina loves functions. Nice, I'm glad you do. Some people hate them. Trust me, when you get to A level, a lot of people will be complaining about the functions topic. I mean, I did too. But they're not so bad. It's just playing around with algebra again. Okay, part B. Find h inverse of g of x. So when you have a compound function, you work from the inside out because you have x. It's like you're building, like, you know those Russian nesting dolls? So your innermost doll is x. You're going to wrap that with this function. And then you're going to wrap that with the h function. So you work inside out. Sadly, A level will start at around 7 o'clock. I've got like 3 questions left of this. So it'll start soon. 6, 7. I do not see a 6, 7 anywhere, so I don't know why I'm saying that. Okay, down my pencil. So for this one, you're going to work inside out. So inverse g of x, so g minus 1 of x, we need to find out what that is first. So what you do is set y equal to cube root of 2x minus 5. And we are going to rearrange, and we are going to rearrange this for x to find out what it is in terms of y, and then that's going to be our inverse function. So to get x on its own, here we are cube rooting it, so we're going to cube both sides, so y cubed equals 2x minus 5. Then we want to get rid of this minus 5 from our x side, so we're going to do y cubed plus 5 equals 2x. And then to separate the multiplication, you divide by 2, so x is equal to y cubed plus 5 divided by 2. So therefore, now then just replace this with a g minus 1 of x, and replace your y's with x's to get this. So that is the inverse function of g. Now we need to put this using our little dolls analogy, nesting dolls. We put this function inside h of x. So now put g minus 1 of x into h of x, where that is at. So we have h of x equals 1 over x. So if x is equal to this big fat thing over there, it's going to be 1 over x cubed plus 5 over 2. And we need it in terms of x in its simplest form. So 1 over something, that's just doing the reciprocal. All you have to do is flip the fraction. And if it helps, it's like doing this. 1 divided by x cubed plus 5 over 2. You flip the second part, so you get 2 over x cubed plus 5. And that is your answer to part B for a nice little 3 marks. Let's just charge my phone in the meantime while I just check the chat. Okay, hopefully that makes sense. Hopefully that little analogy of the Russian nesting dolls works. You work inside out. Then just treat each thing one at a time. It's like a wrapper. It's like you're wrapping each function by another function. But yeah, how do you get the reciprocal? Reciprocal, just flip the fraction. So here my fraction was x cubed plus 5 over 2. To get the reciprocal of it, I just flip it, so the numerator goes to the denominator, and the denominator goes to the numerator. So I have 2 over x cubed plus 5. For sure. Ta-da! This is like the easiest A-level topic. No, yeah, this is in A-level. I think it's like, and this is like one of the, this is topic 2 in A-level. Perfect, no worries, Prisha. So that is question 19. Question 20 is a circle theorems question, which was the last question on your paper 1. So I don't think it is likely to come up again. so I'm just going to show you what I wrote for this in preparation while my pen charges, because I don't want my pen to die on my live later. But this is how you would go about working this, and I'm going to walk it through how I would do it. So circle theorems again. So this one, this is 2022 June, yes, and this is GCSE. This is the paper I sat. I thought it'd be funny to do my papers. A level is later. Yep. Okay, so A, B, C, and D are points on the circumference of a circle. They tell us that we've got straight lines. Cool. That's obvious facts. So work out the size of angle CDE. So I've labeled my angle over there. Give a reason for each stage of your working. So I need that. Well, I see that I've got an angle at the center and an angle at the circumference. So that's screaming out at me that angle subtended at the center is double the angle subtended at the circumference, angle at the circumference. So BAD, angle BAD is 132 divided by 2, and that gives me 66. So that is 66 degrees. Then I can see, oh cool, I've got a cyclic quadrilateral. Well, I know that opposite angles in a cyclic quadrilateral add up to 180 degrees. So 180 minus 66 will give me this one over here, which is 114 degrees. Now I've got angles on a straight line, so I've got this, but I want to find out what this is. If I find this, then I can just do angles in a triangle. So angles on a straight line add up to 180, so that's 180 minus 114 to get ECD of 66, because angles on a straight line add up to 180. Then all I need to do is figure out what CDE is, which is the goal of the question. So CDE is 180 minus 66 minus 16 is equal to 98 degrees, because angles in a triangle add up to 180 degrees. I don't think this is likely to come up again, since it was the last question of your paper 1, which is why I'm just showing you my preparation material. But this is how you would do it to get full marks. Obviously, you would write full sentences here. I just did shorthand notation for my convenience. However, write out the full sentences. I find if you laid out your work in your paper 1 like this, very neatly with your things there, calculations and your reasons, it would be very nice for the examiner to mark. Maybe they'll be nicer to you and give you the marks much more easily. Awesome. Yeah, this is better than the one you had, because this is not the last question. The last questions tend to be, I don't see the cyclic quadrilateral. It is right there. 4 points and a quadrilateral in a circle. Awesome, guys. Again, thank you for all the likes and all the comments and reposting this live. I really appreciate it. Okay, cool. That is question 20. Now I'm going to go back onto this one and go down. Okay, so we've done that. This one, question 21. Did a similar type. Why is it 114? Because opposite angles in a cyclic quadrilateral add up to 180 degrees. Let me just get that back on the page. You can take a screenshot if you would like a reference. It's basically what's in the mark scheme also says it, but my way is just how it's written out on the paper. So opposite angles in a cyclic quadrilateral add up to 180. So that is opposite that. So 180 minus 66 gives me 114. Perfect. Thank you for answering each other in the chat. That's really nice. Now, moving on. Last 2 questions. We're almost done with this paper. Okie dokie. The graph of y equals f of x is shown on the grid below. So there's my little graph there. Hopefully you guys should recognize what sort of graph this is. You don't need to for a question like this, but it helps to know, like you should know that this is a cubic graph and it's a negative cubic for reference. Okay, on the grid above, sketch the graph y equals f of minus x. So here, the x is becoming minus, which means I'm going to reflect it in my y-axis. So like the x is going minus. So it's like a horizontal thing. That's how I visualize it. So I remember which way around to go. My pen is burning hot. Okay, so what you do with this is you plot the key points. So this x is being reflected here. So make sure you plot all your key points to go through them. So this one is going to be reflected there. This one is going to be reflected 1, 2, 3 here, and this one is going to be reflected 2 more there and there. And now it's just a dot to dot. So you go up here, there, and up. Oh my god, that is perfection, guys. Look how smooth that is. Okay, I mean, it's kind of pointy there, but it's smooth. Okay, when you join these dots up, they will penalize you if you do something like this is your dots, right? If you do this, like you see I've lifted up my pen off. Actually, no, you can't see me lifting my pen off the paper. But if you do it like dot to dot, like in segments, you don't do a smooth curve, you will be penalized. So make sure you do a smooth curve that it's literally like that. That's how your pen should be done. How do you reflect it? Well, it's f of minus x. The x is negative, so I imagine that it's like a switch in this way across, so it's a reflection in the y-axis. So just know that f of minus x is a reflection, reflect in y-axis. And if it's minus f of x, that's a reflection in the x-axis, because the whole y thing is negative, so it's like a vertical thing. So, oh, that's reflecting in this line, x-axis. Let's just check the chat. Pythagoras theorem is a squared equals b squared plus c squared, where c is the a squared equals where a is the hypotenuse, the longest one. Thank you for the roses, Fez. And it is about how you find side lengths of a right angle triangle, Leah. How do you reflect it? Like I showed with the points being reflected across the y-axis here, because it's f of minus x. Thank you for the rose, Toby. Can I go back to the circle theorem? I'll show you the answer to that after I finish part B. And yeah, and this is GCSE. Perfect. For part B, and this one was mean, okay, because I wrote the notation incorrectly, so I lost the mark in my actual exam, but I did the transformation correctly. So make sure you write the notation correctly too. So here's a sketch of the graph of y equals tan x. You should recognize that. So I like to put my points down to make life easier. So that's 360. Nice. And then that's 450. The graph of y equals tan x is translated to give the graph of y equals g of x. So g of x is the name of our new graph. This is Edexcel Firuz. Following the translation, point Q, shown on the graph above, moves to point R, which has these coordinates. So R is 90 minus 5. So let's just say R is there. Find an expression for g of x, so for g of x in terms of x. So we can see we're going from 360 to 90. So 360 minus 90 is equal to 270 degrees left. And it's a horizontal x translation, and x is illogical, it's weird. So if we're going left, we are doing tan of x plus 270. Because if we're going to the left, it's negative typically, but x is weird, so it's going to be positive, so plus 270. So that's the first part. Now it is moved down 5. So, and down 5, and that's in the y direction. So it's going to be outside this thing. It's going to be in the y thing, so it's going to be outside our x bracket thing. And y is logical. A user is logical, y is logical. That's, you can remember y. So then, that's just g of x is equal to tan of x plus 270 minus 5 on the outside, because that's like the y equals thing. And that is your answer. Now I'm going to tell you why I lost the mark here. So I got 1 out of 2 here. I did, so this is what I put as my answer. And this is wrong because it is translated to give the graph of g of x. G of x is not the original graph. So this is what the original graph, if the original graph was g of x, then this would be correct. But no, the original graph was tan of x, which is why I need to apply these transformations to my tan graph, not to the g graph. G is the result. So that's just a mini nuance, which is an annoying thing because I thought I cooked, but I messed up. So make sure you don't mess up. But yeah, that's how you do this type of question. Just do the transformation on the original equation. Don't do it on the new equation. Make sure you know what the original and the new equations are. Hopefully that makes sense. Why are people flirting again in my comments? This happened yesterday. This is just a maths life. Okay, cool. I don't even know what's happening. Okay, back to circle theorem. Yes, I will show the circle theorem's question over here. So this is the circle theorem's question. You can take a screenshot if you'd like. I'll just explain what I wrote down here. Angles in a straight line sum to 180. And then angles in a triangle sum to 180. And then you just follow through the steps there. It's just like working with a puzzle. Use the rules you've memorized and learned, and then just piece together the parts and build up your angles. Sometimes you may find unnecessary angles. There's no harm in that, but just make sure you understand how to work it through. No worries, George. Okay, I think we're on to the final question. And in my opinion, this is a very nice final question of the paper. I don't know where all the working's gone here. Oh, that's annoying. Never mind. It's fine. Okay, question 22. Find algebraically, let's just check my pen works now. 1 second, because my pen has been acting up for a second. Let me just connect it. Is the rubber gonna work? Nice. Okay, my pen is back to normal. This is a very nice 5 markers. If you guys get a question like this, you should be very happy. I mean, I was very happy when I saw this. Find algebraically the set of values of x for which x squared minus 49 is greater than 0 and this thing is also greater than 0. It needs to satisfy both. So satisfy both. And I have a video on this type of question too, so you can check that out on my page afterwards. So I'm going to do the first one first. So x squared minus 49 is greater than 0. So that's x. This is a difference of two squares. So x plus 7, x minus 7 is greater than 0. This was in paper 1. I think this was in paper 1 as well, but I'm going to go through it again just for completeness sake. It may not come up again. It could be a mini version, but you never know. It could be a hard version as well. However, I'm just going through the full paper. So we know that x is equal to 7 or negative 7 from these. So then if I look at that, there's my quadratic, so negative 7 and 7. It needs to be greater than 0, so that's here and here. So therefore, x is less than negative 7 or x is greater than 7. So that's the first part. Now I'm going to solve my other inequality. So 5x squared minus 31x minus 72 is greater than 0. I'm just going to solve the equation first. So x is equal to 31 plus minus square root of 31 squared minus 4 times a times c. So that's negative 72 divided by 2 times 5. And in your calculator, you get 8 and negative 9 over 5. You can also solve this by factorizing, but quadratic formula is just much quicker and easier. And then if I have my graph, we know that it's at 8 and negative 9 by 5. So there's my thing there, and it's going to be greater than 0. So it's the part that is above the graph, greater than 0. And none of them are equal to, so it is a strict inequality. So we know that x is going to be less than 9 over 5, well, negative 9 over 5, which is negative 1.8, or x is going to be greater than 8. Now, I need to satisfy both of these at the same time. So I need to find where they're both met at the same time. So I do my little number line, big number line actually, have 0, and then I'm just going to put these inequalities on my number line. So I have negative 7 over there, and x is less than that. So it's going to be a hollow circle, or 7 there, and it's going to be greater than that. Again, hollow circle. X is less than negative 1.8, so it's going to be less than that. Or x is greater than 8, so 8 is there, so it's going to be greater than that. And I need to find where these overlap. So here, this is the bit where they overlap. And here, this is the bit where they overlap. And then I just take the more extreme inequality. So here, x is less than negative 7, or x is greater than 8 here. And that's my answer. X is less than negative 7, x is greater than 8. And that is a wrap on the 2022 GCSE paper 2. I hope that makes sense. This was a very nice ending to the paper, and that is how you would do this paper. Hopefully that explanation worked for everyone. Where did the 1.8 come from? Let me just scroll down. 1.8, I just converted the fraction into a decimal. So 9 over 5, negative 9 over 5 is negative 1.8 as a decimal. But yeah, I will be moving on to the A-level paper in 2 minutes, but let me know how your exam goes tomorrow. Feel free to DM me or put in the comments of some of my videos. I would love to hear how it goes. Hopefully this live helped you out. Hopefully it cleared up some of your doubts. Thank you for all the likes, the gifts, and the support you guys have given me in this one. I will be doing lives for GCSE paper 3 again next week. So I will post the dates in due time. So they'll be on my page. No worries, guys. But yeah, thank you all for being part of this one. And yeah, let me just check any questions. The transformation, which transformation question, Melina, did you want me to go through? The first one or the second one? I'm assuming the second one. So I will just keep that on the screen. It's about scale factors going in the opposite directions. Question 21. Oh, yes, question 21 here. This transformation question, yes. Let me just pull up my solutions version because the text disappeared. So here, we know that Q is over here at 0, at 360, 0, and R is at 90, negative 5. So we can tell it's gone 270 degrees to the left and 5 parts down. So a translation in the x direction, left, is illogical x. So it's tan of x plus 270. So that's the first part to get it from here to here. And now I need to go down. So 5 units down is in the y direction, and y is logical. So it's going to be outside my x brackets. So it's going to be minus 5. So to get down to r over there. So g of x, which is my resulting graph, is equal to tan of x plus 270 degrees minus 5 on the outside. That's how you work it through step by step. See how to go from one to another. Do your x shift, do your y shift, and then you should be good to go. Hopefully that helps, Melina. But yes, that is a wrap on the GCSE paper. Just going to keep the A-level paper title page on the screen. Okay, A-level time. No worries, Melina. Good luck for your exam. Let me know how it goes. Hope it goes well for you all. But yeah. So A-level, I'm going to be starting soon. I am in university, Wolfie. Completed my A-levels 2 years ago. Okay, I'm just going to take like a little 1-minute break before we start. Feel free to just ask any non-related stuff questions, because I just finished the GCSE paper and now we will be moving on to the A-level paper. It's funny, both of them are on the same day in both exams. So I can't wait to see what both papers look like. I'm hoping they go well. Hopefully they go well. They shouldn't be too bad, hopefully. This paper is the 2024 paper, if you would like to follow along. And like it says on the screen, this was the paper I sat 2 years ago. And this is the paper 1 I did. So most likely I may be going through the paper 2 of 2024 in my next live stream before the paper 2 exam next week. Okay, I am going to start in like half a minute. This is A-levels, Maya. Hopefully they go well. GCSE paper 2 tomorrow. Best of luck, Wolfie, with that. Hello, Saeed Yusuf. Welcome. Okay, cool. We've got a lot of people in the live stream. Hi, everyone. I'm going to get started right away. So this is the 2024 pure paper 1 for Edexcel. And this has got different questions generally to the ones I did in my live stream yesterday if you were there too. Okay, we're going to get started right away. So we have g of x is equal to this thing here, a cubic function. This is A-levels DM, so there's just one level of that, where k is a constant. Given that x minus 3 is a factor, find the value of k. So we see the word factor, we think of factor theorem. Exactly, make it equal to 0. So by the factor theorem, if x minus 3 is a factor, f of 3 is equal to 0. Sorry, g of 3 here. G of 3 is equal to 0. I like to write this out at the top just in case, it might be a mark. So g of 3 is equal to 3 times by 3 cubed minus 20 times by 3 squared plus 3 times k plus 17 plus k. And we know that's equal to 0 because it's a factor. So if I put this into my calculator and evaluate that, that's 3 times, that's 81 minus 3 times 180 plus 3k plus 51 plus k is equal to 0. And then I have 3k plus k is 4k. And then I do 81 plus 51 minus 180 is minus 48. And that's equal to 0. So 4k is equal to 48. Therefore, k is equal to 12. Very nice 3 marks. Yes, Fred, this is A-levels. So very nice little 3-marker factor theorem question to start off the paper with. Hopefully that makes sense. Just in my opinion, my recommendation, just state the fact that if x minus 3 is a factor, then g of whatever is equal to 0, just so they know that you know what factor theorem is. You can also do this by division, but I don't know why you would do that. That's much longer. Okay. Question 2. A very significantly easy binomial expansion question compared to the monstrosity we did yesterday. find in ascending powers of x the first four terms of the binomial expansion of this. We can see that n, our power, is a fraction, so we need to use this formula, and I'm going to write the formula out in blue for you guys. 1 plus x to the power of n, and this 1 has got, well, this 1 has got to be a 1. This is not in further maths for GCSE. This could be in further maths for A-level, but it's not explicitly, like, because A-level further maths assumes A-level normal maths content. So the formula is 1 plus nx plus n times n minus 1 over 2 factorial x squared plus blah 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 plus n times n minus 1 all the way to n minus r plus 1 divided by r factorial times by x to the r. I hope you can see that. Oh, that's just off the page. There you go. Cool. So that's your general formula, and all you got to do is sub into the formula, and we need to give each term in its simplest form. So we have 1 minus 9x to the power of a half. That's going to be equal to 1 plus nx, which is a half, times negative 9x. You take whatever is with your x. You don't have to memorize this formula, Wolfie. Oh wait, you're doing GCSEs. Yeah, this is not a formula you have to memorize. But if you're doing the step maths exam, you will have to memorize this potentially. And then plus a half times by minus a half divided by 2 factorial times by minus 9x whole squared. Put the whole thing in your squared. And then this is 1, 2, 3 terms. They want 4, so you just do that one more time. It's always following the same rule. It's actually quite a nice little formula in my opinion. It's intuitive, 9x cubed. That's a 3 there, by the way, on the side, which is just in the margin. So then if I simplify this, I have 1 minus 9 over 2x minus 81 over 8x squared minus 729 over 16x cubed plus blah blah blah. I put the plus dot 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 because it is an infinite expansion. And that is it. That's my answer to part A for nice little 3 marks. Hopefully this makes sense tomorrow. Hoping for a big mark question on IBP. Yes, hopefully. Don't be scared for tomorrow, guys. I'm gonna try and reassure you through this live stream that it's not so bad. And this is the paper I did, so you know this is bringing back a lot of memories, and I'm gonna walk you through what I thought and how I felt. So part B, give a reason why x minus 2 over 9 should not be used in this expansion to find an approximation to root 3. Well, the one thing we didn't do with our expansion is state the validity range. So whenever you do a binomial expansion all of year 2, just state the validity range anyway. So validity range, we know we just take our correct, like the layout matches the formula, whatever is along with this x. So you have 9x should be, the modulus of 9x should be less than 1. So therefore, the modulus of x should be less than 1/9. Well, we can see that, and negative 2/9 is outside this range. Why? Because the modulus of negative 2/9 is greater than 1/9, because 2/9 is greater than 1/9. That's why it shouldn't be used. Hence, it should not be used. So that's just validity ranges, is like what we discussed yesterday. And as you can see, they didn't ask for it, but I recommend to do it anyway because it could be useful. This is not GCSE, don't worry. This is A-level paper. Okay, nice. By the way, this is A-level content, top right. So if you're doing GCSE, don't listen to this stuff. This is my foreshadowing if you pick A-level next year. Okay, hopefully that makes sense so far. No, I did GCSE from 5:30 to 7. I just finished that. I'm doing A-levels now. The live is recorded. I'll try and put it on my YouTube as soon as possible afterwards, so you can check it out there. Okay, as long as TikTok doesn't give me issues with exporting the video. Nice. Cool. F of x, they're giving me another function, is equal to x plus tan half of x, where x is between pi and 3 pi over 2. So I'm dealing with radians, so I make a note of that, and I make sure my calculator is in the right mode. No worries, Wolfie. I'm glad you find this cool, because that's just fun. Anyway, I sound like such a nerd saying that. So, given the equation f of x has a single root alpha, show that alpha lies in the interval 3.6, 3.7. So, I like to write out my function again just so I know I understand it. F of x equals x plus tan half of x. And if I want to show it lies in an interval, that a root lies in an interval, I just have to substitute in my values of the interval and show a change in sign. It's as simple as that for 2 marks. Well, with my conclusion too. So f of 3.6 is equal to 3.6 plus tan of a half times 3.6. And then I do f of 3.7 is equal to 3.7 plus tan of a half times 3.7. Put that into your calculator and you get a negative answer here, negative 6.86, blah, blah, blah. And I like to say it's less than 0. And I'm hoping for a positive answer when I put this in. And indeed, I do get one. I mean, I have to, otherwise the question will be wrong. And I like to say that's greater than 0. So I'm very happy. So I say, therefore, there is a change in sign. That's my first part of this explanation on the interval 3.6 to 3.7. And since, and then this is the second part of the explanation, f of x equals x plus tan half of x is continuous, is a continuous function over the interval. So it's continuous over the interval. Then you say the last part, there exists a root, and they've called the root alpha, in the interval 3.6, 3.7. There exists the root. So the stuff I've underlined are the main parts of the marked scheme. This is 2024. Yep, Adriel. Hi, Sadalia. Yep, we're doing A-level stuff now. And that's how you get the 2 marks. So pretty standard, just sub in, and this is how you do finding roots. And then the conclusion you guys should have hopefully memorized by now is you should just do that. Why do I have to say it's continuous? I have to say it's continuous because there's no vertical asymptotes there. Because if I had a vertical asymptote, then the sign could change. For example, here we can see the reciprocal function as I'm sorry, that is a terribly drawn reciprocal function. So here I've got a reciprocal function, right? So if I have minus 5 here and I have 5 here, and I say that, okay, there's a change in sign here and here because this is negative and this is positive, then there's a root there. But here, I clearly don't have a root. I have a vertical asymptote, which is why I need to say the function is continuous. So this is not continuous. Hence, there's no root. But if it's continuous, as in it doesn't break up. Continuous means it continues, right? It doesn't break up like this. So we can see in this interval, if I have a value here and here, this is positive, this is negative. We indeed do have a root here, and because it's continuous, it doesn't jump like this does here, then I have a root. That's why I have to say it is continuous over that interval. Hopefully that explanation and those diagrams make sense. It's mainly to do with vertical asymptotes. So we don't have any vertical asymptotes with continuous functions in that interval. Okay, nice. Awesome, no worries, KXF. Then we need to find the derivative of f of x. So very nice little differentiation question. It's a mini differentiation question here. So f dash of x is equal to, if we differentiate x, we should know that that is 1. Don't forget the basic ones. And then if we differentiate this, we get plus a half sec squared over half x using the chain rule, because tan kx differentiates to k sec squared kx, and then the k is a half here, so that's just outside. Very nice. So I'll just put the rule here if you want. So if y equals tan of kx, dy by dx is equal to k sec squared of kx. So that's the rule I used. Very nice. Part C, well, you can guess what part C is because you've got f of x and you found the derivative, is going to be Newton-Raphson method. So using 3.7 as a first approximation for alpha, find a second approximation, give your answer to 3dp. So I like to write 3dp at the top. And all I need to do is apply Newton-Raphson once. Quite nice. So I like to write on my formula. So x of n plus 1, which is my next term, is equal to the previous term minus the function with the previous term value divided by the derivative function with the previous value. That's it. That's what I need to do. And all I have to do is plug into the formula. Even if you don't understand what Newton-Raphson is or how it works, literally just write out this formula and find the missing parts and then just plug in. So we know that x of 1 is equal to 3.7, and we just follow an iterative process. X of 2 is equal to and we just need to find a second approximation because this is the first. So we just need to do this once. 3.7 minus, and then f of x of n, well, we know that is this thing up here. So if I write that out here, I like to write out the full things. 3.7 plus tan of a half times 3.7 divided by the derivative function, which I have found myself, plus a half sec squared of a half times 3.7. And if I put that into my calculator, I get 3.67223 decimal places. And that's how I do that. Yep, 2024 A-level paper. Thank you, Arlo, for answering Mert. Now, the thing I want to point out here, which is an underrated thing, kind of, is how do I actually write sec squared in my calculator? Because I don't actually have that. Well, we know that since, I'm just going to write it out explicitly for you guys. So since sec of x is equal to 1 over cos of x, this is what I typed for my denominator. I typed 1 plus a half, I just wrote 0.5, cos of a half times 3.7 to the minus 2. Because I'm doing it to the minus power because it's 1 over cos, and because I have sec squared is 1 over cos squared in the calculator, because then that leads to 1 over cos squared of whatever. So that's how I would write it in the calculator to make it easier. Exactly, Satalia. Yeah, there is 6, 7 here. This is 2024 paper 1, Yuha. Okay, and is that it? Yep, that is part A, B, and C done. So very nice 3 marks of just applying what we know from topic 10 of year 2. I think it's topic 10. It's the orange one in the textbook. But yeah, hopefully that makes sense. Very nice question, in my opinion. Moving on. Okay, this has got to be the best first principles question of all time because it is the most standard like derivative ever, x squared. What you differentiate. When I saw this, I was laughing in my throat, like laughing internally, obviously, you know, not breaking exam rules, but I was so happy when I saw this. It wasn't obnoxious. So I'm going to explain this quite quickly towards the end, obviously, because there are still some people who are learning this. So f of x is equal to x squared. So f dash of x, I like to state out the formula first, is the limit as h tends to 0 of f of x plus h minus f of x divided by h. And now I need to, my f of x is equal to x squared. So wherever I have that, I will just replace that there. So that's the limit as h tends to 0 of x plus h squared, because x is now x plus h, and I put that into that. So that whole thing is squared. This is AS level as well, this question, but this paper is an A-level paper. And then I'm doing minus f of x, which is minus x squared divided by h. And now all I have to do is play with some very simple algebra. So we do x squared plus 2xh plus h squared. No unnecessary binomial expansion needed there. Divided by h. And it gets better because we see x squared cancels with x squared. So we have lim as h tends to 0 of 2xh plus h squared divided by h. And cool, everything has an h term as I want. So then I do the limit as h tends to 0 of 2x plus h. And that's it. Well, not quite yet. That's the algebraic fudging. Now I just need to be formal and say as h tends to 0, 2x plus h tends to 2x. So I have my little conclusion. Therefore, if f of x is equal to x squared, shockingly, f dash of x is equal to 2x. And that is my favorite ever first principles question. Very nice question. I don't think that you'll ask this question again, but this is the process of how to do it. Hopefully the process makes sense to you guys of what to substitute where. But yeah, and then you want to cancel out your h's, and then you show as h tends to 0, what happens to your overall algebraic expression. What does that tend to? And it should tend to what you want to show. And that is all you have to do. This is A level, yes. This is also an AS level. And this is a very nice, easy question. I mean, free 3 marks in this exam. So make sure you don't screw up on the easy questions too. Don't be overexcited. Okay, keep composure. Then we move on to another, in my opinion, pretty standard question. The function f is defined by this, where x is the member of the set of real numbers. Show that this thing, where f dash of x, Oh, cool. All I have to do is differentiate this. Again, so some more differentiation. We have done a lot of differentiation in this exam already, and we get more. And this one, we don't even have any problem solving. We know we have to use the quotient rule. Why? Because we have y is a fraction. Basically, y is equal to u over v. So if we have dy by dx, and for reference, I'm going to write out the formula, is vduv. I remember v du by dx minus u dv by dx. There's your vduv there, divided by v squared. So that is the formula. All you gotta do is sub in. I like to write out my u's and du's and all beforehand, just so I've got that clearly done. So u is equal to the top part, that's u, and v is the bottom part. So u is 2x minus 3, and it's not difficult to differentiate this. That's just 2. And then v is equal to x squared plus 4, and again, a very basic differentiation is 2x. So those are your year 12 differentiations. Now we have to do the year 13 part and put that in. So I like to rewrite my thing just to make sure I've understood what my expression is. X squared plus 4. So f dash of x is equal to, and then you have to do 2 times by x squared plus 4 minus 2x times by 2x minus 3 divided by v squared, which is x squared plus 4 whole squared. Now looking at this, this is what I wanted to show, right? So I've got my v squared on the bottom exactly as it is. So I'm not going to do anything to that. I'm not going to expand it or anything. I see exactly v squared is already on the bottom. So I just keep that as is. I'm just going to play around with whatever is in my numerator. So 2x squared plus 8 minus 4x squared plus 6x. And then that's all over the same thing as before. Then we do 2x squared minus 4x squared, so that's minus 2x squared plus 6x plus 8 divided by x squared plus 4 whole squared, and that is my answer. Let me just check. Yep, that is my answer. Nice. So we can see a is equal to -2, b is equal to 6, and c is equal to 8. That's how you do the first part for a very nice 3 markers quotient rule. This whole paper is so for just differentiation, and there's some more differentiation later on in the paper. I was very happy when we were sent this. Okay, cool. Part B. Hence, using algebra, find the values of x for which f, the function, is decreasing. So when we see decreasing, we're thinking negative gradients. So we should remember from year 12 differentiation, we decrease if f dash of x is less than 0. The gradient is negative. So we know that what is my gradient function is this thing I found over here. So I'm going to say that minus 2x squared plus 6x plus 8 divided by x squared plus 4 whole squared is less than 0. Well, I can just multiply out by the denominator. So minus 2x squared plus 6x plus 8 is less than 0. Cool. Now all I have to do is actually just solve a quadratic inequality. So I'm going to just move this down here. So I'm going to bring everything onto one side, minus 6x minus 8. Check my signs are right. Yep, cool. So I'm going to divide through by 2. X squared minus 3x minus 4 is greater than 0. So I know that x is going to be equal to 4 or -1 if I solve this as an equation. So when I do my little graph, I need that to be greater than 0, so it's going to be there or there. So x is going to be greater than 4, or x is going to be less than -1. And that is where f is decreasing here. And that is it. Very nice. dy by dx is less than 0. Exactly. So 6 marks, guys, for some differentiation and some decreasing functions. You need to remember what your terms are. So decreasing and increasing functions, stationary points, convex, concave, all of that. Make sure you know the rules for your first derivatives and your second derivatives with those, and you should be good to go. And make sure you know how to obviously do differentiation. Okay, question 5. So far, so good. This is turning out to be a very nice paper so far. Trust me, it does get longer from a certain point. Like some of the questions towards the end get quite long. I'm going to keep this question on the screen for a second for you guys to have a read through. Okay, so this is the functions question, and there's going to be a lot of drawing involved in this one, so let's get right into it. Figure 1 shows a sketch of the graph with the equation y equals 3 times the modulus of x minus 2 plus 5. Yeah, this tends to be one of the most hated topics in A-level maths. for, for no reason. I mean, for a reason, I didn't like it too. They're just fudgy, in my opinion. It's just, yeah. The vertex of the graph is at the point P shown at figure 1. There's your vertex where it changes direction. Find the coordinates of P. Now you might be thinking, how does it come to coordinates? Well, what I like to do is, I hate when it comes to coordinates. Yeah. So what my trick is I take the modulus part of the function first, and because you can see we've got a modulus function of x minus 2, and we transform it by scaling it vertically by 3, and then shift it vertically by 5. So what I do is I like to first graph out the modulus bit as it is. So we know x minus 2. So we know that negative underneath the x-axis, there's going to be nothing. So it intersects at minus 2 here, and then it cuts there, and then it goes up. So that is my graph, but the thing that's under your x-axis, because it's all modded, it's turned positive, it goes upwards. So if it was minus 2 down here, it's going to come to plus 2 over here. And because the gradient is just 1, this is also going to be 2. So you can see that originally my vertex, vertex is originally at 2, 0. Now hopefully you guys can see why finding the vertex of point P is not so bad, because if the original vertex is over here at 2, 0, and P, this graph is a transformation of a stretch by 3 in vertically and moved y by 5 vertically. So a stretch of this point by 3 is going to keep it at the same point. So after 3 lots of x minus 2, we still have it at 2, 0, because y is equal to 0, and 0 times 3 is 0. Then after 3 of x minus 2, and we shift our graph up by 5, well, this y value is going to move up by 5, so then you get 2, 5. And that is my p value. And that's it. P is 2, 5. Exactly, Wolfie. So hopefully that shows you guys it's not so bad. My trick is sketch the modulus graph as it is without any of that fluff. And then the stretch, why does the stretch not do anything? Because you're multiplying the y value, right? It's a vertical stretch. The y value here is 0. 0 times 3 is 0. It's like taking this and like stretching it up. Where's my pen? It's like stretching it upwards like that. That's what the stretch does. It makes it skinny. Imagine you've got the rubber bands and stuff. You stretch it upwards. If it's like you've got a rubber band here and it's tied to my pen and I'm pulling it up, it's getting stretched, but that thing where it's tied to my pen doesn't move. That's how the stretch works. That's how I like to visualize it. So hopefully that helps. Okay, now this is where it gets long and a bit annoying, but it's not so bad, but it's just not nice. Solve the equation here. So the right side is my graph, and then the left side is 16 minus 4x. So when solving the equation, the modulus part can be positive or negative. So we need to see first, where do these lines actually cross? So we need to see this graph is y equals minus 4x plus 16. We're basically finding the intersection of this graph and this graph up here that we started with. So I'm going to do it in blue so you guys can see. So we've got a gradient of negative 4x and we have an intersection of 16. So we are going to have it going like this. So we can see that this one is steeper than this one over here because the gradient of P is technically 3, kind of. This is a gradient of 4. I've drawn this terribly. 1 second. So this is there. And this gap over here is going to increase as we go up. So there's only one point of intersection. No, I wanted that line. There's only one point of intersection over there. And that point of intersection is where we've got the modulus part being positive. So if I go back down to my lines, so there's one point of intersection where the modulus bit is positive. So if I take the positive part, I have the modulus bit was x minus 2, so then that will become x minus 2. We do not have this minus sign there. If it was negative, we'd have that there too. So I'm just solving this equation, and it's just a simple linear equation to solve. 3x minus 2, you see the modulus is positive there, plus 5. So if I just solve this real quick, I get 3x minus 6 plus 5, and then I have 7x equals minus 5 minus 17, then x is equal to 17 over 7. And that's it. I do not need to find the y value because the question asked me to solve the equation. Solving means finding whatever letters in that equation, so x. So I don't need to find y there. So that's that. Hopefully that makes sense for you all. Now for part C is where we have to do a bit more like logic-y problem solving work. So I'm going to do some more drawings. So a line L has the equation y equals kx plus 4, where k is a constant. Given that L intersects this line, so my original line here, at two distinct points, find the range of values of k. So what exactly is k in this equation? Let's establish k is my gradient. So I need to find the range of values for my gradient for a fixed y-intercept. So my y-intercept is 4, and 4 is going to be about like down here. And we know that over here, p is 5. So we know that 4 is down there. So I need this line, which has a gradient of k. So it could be like there, it could be there, it could be there, it could even be there. Those are my potential lines with different gradients, but the same y-intercept. We needed to have 2 points of intersection. So I need to see what are my extreme cases and my non-extremes. So if I have this where it just touches at p, that is my 1 point of intersection. So anything greater in this part would mean 2 points of intersection. So I know that it's got to be greater than this k1 gradient. So k min, let's call that k min. So it's got to be greater, strictly greater than that, because if it's equal to that, then it's just 1 point. Then what's my maximum value? Well, if I've got this as parallel to my gradient of my modulus function, then it's never going to touch again. It's only going to touch once. So this parallel means it's k max, and that's 3. We know that because we look at the gradient of our transformed function there, 3, because we multiply the x by 3. So we know that that is the max. So anything below 3 will eventually intersect. For example, if it was like 2.9, it would be a little less steep than 3. So it will like touch here, and then it will cross there twice. So that's pretty much it. I just need to find what is my gradient of this. Well, I know that here, this line goes through 0, 4, and it goes through P, which is 2, 5, I believe, from what we found. So all we got to do is find the gradient at that. So we know, so for part C, the k is equal to 5 minus 4 divided by 2 minus 0, just finding y1 minus y2 divided by x1 minus x2. And that's equal to a half. So k has got to be strictly greater than a half, because if k is a half, they touch at 1 point, the vertex P. And we know that k has got to be less than 3, because if it's equal to 3, they're parallel, they never meet again, they only touch once. So, therefore, a half is less than k, which is less than 3. And that is it. So looking at it, that's actually not too bad, like with my little visualizations and understanding what is actually happening with the graph, hopefully. Let me just check the chat. So why couldn't it be a negative gradient? It can be a negative gradient, but let's see why that will not work. So I'm going to do it in, what color do I have left? Green. If it's a negative gradient, it would be something like this, right? So it could be there. And if it's 0 gradient is there, so it's only going to touch once. I need it to go across and touch twice. This is a really messy diagram, but I need it to cross twice, which is why I want a positive gradient to make sure it is greater than this part, so it makes sure it at least touches a vertex and something else. And if it's parallel, it's never going to meet, because remember, parallel lines always run by each other. They never touch. So if it's 3, then it's going to go at the same rate of increase as my original black line here, but never meet. So it's going to be less than 3, because 2.9 is less deep, so it'll be a bit shallower, so it will eventually cross up somewhere. That's how you work through that. Let me just change my color back. Okay, cool. Glad it makes sense. So yeah, when I got this question in my exam, wasn't too happy, but I didn't complain because it was only 2 marks. How did I get the max? It's about parallel lines. So we know that if 2 lines are parallel and they're not the same line, they're never going to meet. So here we want 2 points of intersection. So it intersects there for sure once. But if it's parallel, you can see they're running side by side. So it's got to be less than 3, which is the max. And we know that 3 is the max because the gradient here is 3 times something of x. So 3x minus 6 plus 5, that's your equation there. Okay, nice. That is question 6. We're already almost kind of halfway through the paper. I mean, they get longer now, but this is question 7. And guys, shocker, there's some more differentiation happening. This paper is just filled with differentiation and differential equations. I love differential equations. Like, even at further maths level, they're fun. They're just a lot longer at further maths level. Okay, cool. Hopefully you guys get a lot of questions that you like. If you like differentiation, I hope you get a lot of differentiation questions. Figure 2, I mean, it is a very big topic, so it could come up. So, figure 2 shows a oh my god, I can't read now. Figure 2 shows a cylindrical tank of height 1.5 meters. They've annotated that there. Initially, the tank is full of water, so that's at time t equals 0. The water starts to leak from a small hole at point L on the side of the tank. So just underline that. While the tank is leaking, the depth h meters of the water is modeled by this differential equation. So we see the rate of change of the height is equal to this negative exponential, where t hours is the time after the leak starts. So t hours, put that in big, don't mess up. You want to make sure your units are correct, because if you look later, there is something to do with the units, like down there. But you want to make sure, just in case, you know what units we're using. Using the model, show that h is equal to something where a and b are constants to be found. So we know this is differential equations because we've got a differential equation here, and we're solving for a function of the top letter h. So when you solve differential equations in A-level maths, all you have to do is separate the variables. In other words, bring everything of the top letter on the left side and bring everything of the bottom letter and the bottom letter on the right side, in very plain terms. So for part A, we are going to bring all the h-related terms for which we have nothing on the left side, and dt we're going to bring onto the right side. And if you have dh and dt, we can just integrate both sides. So if I write that out, dh by dt is equal to minus 0.12 e to the minus 0.2 t. So I'm going to bring this up here. There's no h terms, so I'm just going to have integral of dh is equal to the integral of minus 0.12 e to the minus 0.2 t with respect to t. Now you see that we have the dt on that side. That's like your little sign that, oh, you can integrate it with respect to t. So if I integrate that, integrating dh, well, here you just have an imaginary 1. So here you just get h. And if you integrate this with an exponential, you have the exponential part there stays the same, so e to the minus 0.2t, and you divide minus 0.12 by your coefficient of t. So minus 0. I'll just write it out on the side so it's clear, divided by minus 0.2, and then that gives me 0.6. So 0.6 e to the minus 0.2t plus c. Why? Because it's an indefinite integral. So we have this as your equation, h equals 0.6 e to the minus 0.2 t plus c, and you can check if you've integrated correctly by just differentiating it. So if you have e to the kx, if you differentiate that, you get ke to the kx. So if I've got e to the 0.6 e to the minus 0.2 t, and I do 0.6 times minus 0.2, I do get negative 0.12, which is what I had before, so I have integrated correctly. Remember, if you want to check you've integrated correctly, just try and differentiate it and see, do you get the result that you had at the start? Okay, nice. So am I done with this question? Is it in this form? Nope, because I don't have b. I'm missing what b is. So I need to find the constant using my boundary conditions. And I've so conveniently written my boundary condition here, t equals 0. What is, my tank is full, so the height is 1.5. So I like to write that out at t equals 0, h equals 1.5 because it's full. So we have 1.5 equals 0.6 e to the minus 0.2 times 0 plus c. So that's 1.5 equals, this is all 0, e to the 0 is 1, so 0.6 times 1 is 0.6 plus c, therefore c is equal to 0.9. I went through that kind of fast, exactly, Sadalia, but that's just about substituting in our boundary condition. So now I have c. So I've used that fact, so therefore my non-differential equation, so my formula is h equals 0.6 e to the minus 0.2 t plus 0.9. where A is 0.6 and B is 0.9. So that is how you do a differential equation by separating the variables for 3 marks. Sadly, it is only 3 marks, but it is not a bad 3 marks. Pretty standard. This is the 2024 paper, Charlie. Paper 1. Pure paper 1, Edexcel. Okay, so hopefully that makes sense, guys. We are going to move on to part B and part C, which is more standard, but we got to read the questions very, very carefully. And this thing is going to come very handy in this one. So find the time taken for the depth of the water to decrease to 1.2 meters. So that's the result. So that's my H. Give the answer in hours and minutes to the nearest minute. So this is literally what I wrote in my paper. Hours and mins nearest min. Next to the letter B. I wrote that at the top. Yep, this is about rates of change. This is like problem solving with that, and differential equations. It's a combination of all these topics. So, hours and minutes to the nearest minute, right at the top, so you know. So we know that the height is equal to 1.2. So all you have to do is just solve an equation. 1.2 equals 0.6 e to the minus 0.2 t plus 0.9. And now we just have a bit of fun doing a bit of basic algebra. So 1.2 minus 0.9 is 0.3 equals this thing here. Now I can divide through by 0.6 because I want to take a natural log because what I'm solving for is in my power, so I need to take a logarithm somewhere. So I'm going to get rid of the 0.6 by dividing through by 0.6. So I have a e to the minus 0.2 t equals 0.5. That's yep. Then I do natural logs of both sides. So that's minus 0.2 t equals ln of 0.5. So t is equal to ln of 0.5 divided by minus 0.2. Put that in your calculator and you get 3.465 blah 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 hours. The unit was hours. What do I want? Hours and minutes. So I need to convert 0.465 blah 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 into minutes. Well, I know that 1 hour is equal to 60 minutes, so I just multiply this by 60. So times by 60, that gives me 27.9 blah blah blah, which is 28 minutes to my nearest min. So therefore, the time to decrease to 1.2 meters is, don't forget the 3 part, 3 hours and 28 minutes. And that's how you do part B. Very nice part B. I did do 0.3 divided by 0.6 and I got 0.5 because it's a half. Well, then this is the 2024 paper 1. Okay, that was part B. Very nice. Now for part C, in the long term, so I'm thinking as t tends to infinity, the water level in the tank falls to the same height as the hole, which makes sense, right? Because it's not gonna, this part cannot fall out above. Find, according to the model, the height of the hole at the bottom of the tank. So when you see the phrase long term, you think t goes to infinity. So C, as t tends to infinity, we have our function h equals 0.6 e to the minus 0.2 t, well, plus 0.9. That is going to tend towards 0.9 because e to the minus 0.2 t tends towards 0. In your calculator, type that in and type it in with increasingly large values of t, and you'll see it tends towards 0. So 0 times 0.6 goes away, so it tends to 0.9. Therefore, just put your little statement. Therefore, the height of hole from the bottom, and make sure it is actually indeed from the bottom and not from the top, is 0.9 meters. Put your units, or you can put 90 centimeters. But yeah, so that is how you do part C of this little differential equations question. Hopefully that makes sense, guys, and hopefully you're not finding it too bad. Let's just check. I'm not sure what the AQA exams for A-level look like. I did Edexcel. If they're similar, then I will go back down. If they're similar, then this should work. Obviously, you know, I'm going to be shameless and I want people to stay on my life, but make sure you do what's useful. Okay, so this is how I would lay out my working and how I would answer it. Make sure you put your steps clearly, and put words so the examiner also knows what you're doing and they have a good time marking your paper. Make it fun for them. In my exam, I put like exclamation marks and stuff around when I had to write paragraphs. I rubbed it out just in case, but like I tried to make it fun for the examiners. Okay, cool. Question 8, another functions question. This is kind of similar to the first one, but it's like the other part of this red topic, orange topic in the book. Okay, cool, but this one is not so bad, and I did a GCSE question similar to this, and they gave the same amount of marks, surprisingly. So, the functions f and g are defined by these, and we're just looking at these. These are restrictions on our domains. So then for part A, find f of g of 2. And in my GCSE live, if you were there, which I doubt you were if you're doing this live, you work from the inside out. And I said it's like Russian nesting dolls. So you first find what g of 2 is, then you find what f of g of 2 is. So for g of 2, so f of g of 2, g of 2, you just plug in 2 there. So that's f of, ignore that. 5 divided by 2 times 2 is 4 minus 9. And I'm finding f of minus 1. And if I'm finding f of minus 1, I'm just plugging in minus 1 into f. So that's 4 minus 3 times minus 1 squared, and that's equal to 1. Very nice little answer there for 2 marks. Amazing. Part B, find the inverse function of g. So remember, you just said y equals to your function, 2x minus 9. And then you rearrange for x. So you've got 2x minus 9 equals 5 divided by y. So I've just multiplied by that and then divided by y. Then you've got 2x equals 5 over y plus 9. And then I'm going to divide both sides through by 2. So x is equal to 5 over 2y plus 9 by 2. And I'm going to put my fractions together. So I have 5 plus 9y divided by 2y. And I just need to state that this is my inverse function formally at the end. So therefore, g minus 1 of x is equal to 5 plus 9. Make sure you put x there and 2x there. And I need to state my domain for this. So we know that the denominator cannot be 0, so x is not equal to 0. And that is my answer. You can also put like this as well, but it's important that you have this. So that is how you find the inverse function. And if you have any restrictions on the domains, make sure you put them too, because that could be a mark in itself. Awesome. So for part C, find gf of x. So we're just doing another compound function, giving your answer as a simplified fraction, and then deduce the range of gf of x. In my opinion, part 2 is one of the more obnoxious questions. Part C1 is pretty standard. So C1, you want gf of x. Make sure you go the right way. So you're finding g and f of x was 4 minus 3x squared. That's what they gave us in the question. And for putting that into g, we're just putting that over here where that little x is. So then that's equal to 5 divided by 2 times 4 minus 3x squared minus 9. And now I just need to make this a simplified fraction as the question said. So just clean that up. So 5 divided by 8 minus 6x squared minus 9. And that is equal to 5 over minus 6x squared minus 1. That is my g of x function. Do I have any restrictions there? Nope, because this cannot be equal to 0, so I'm fine. Nice. Looking at the next part, deduce the range of gf of x. So when I saw that, I was angry in this exam because it's not the nicest thing to deduce the range to, and I'm going to show you what I did to get the mark in the paper. Hopefully it makes sense. So this one, the range, so this is my function. We know that the minimum value is when the denominator is at its maximum, right? Because to find the smallest possible value this could be, you make the bottom number very, very big. So we know that minus 6x squared minus 1 is max when minus 6x squared is equal to 0, because that's the biggest it can be, because it's a negative quadratic. So this is minus 1. So that's going to be equal to 5 divided by 0 minus 1, and that's going to be equal to minus 5. So that's the minimum value that this could be in our range. Exactly, Jen Sakai, negative 5. So we know that negative 5 is less than or equal to g f of x, and it can be that because we've clearly shown it's equal to that, so it includes it. But we also have, but it's also less than 0 because it's like a reciprocal function with an x squared on the bottom. That was my reasoning there, but like bounces there, so it's negative 5 there. And as you can see, you got your horizontal asymptote at y equals 0. So you know it is strictly less than 0. It's never going to touch 0 because of how asymptotes work. So therefore the range is negative 5 is less than or equal to g f of x, which is less than 0. And that's how I worked it out. So it's not equal to 0, it's less than 0 because of the way that the asymptotes work. So this is like a reciprocal type function. So this is what I pictured it looking like in my head. And like you can plot out a few points and then just see roughly where it goes and then get the general shape, and then you find that it works like a reciprocal function of negative k squared. So like 1 divided by negative k squared gives you this shape. And you know that with reciprocal functions, you've got an asymptote at y equals 0. And it's less than that strictly because it can never be that. And we know that it goes down to negative 5. So that is how that works. I'm hoping it's saved because this likes to bug me. Thank God it's saved. Okay, cool. This question is still not done. We've got part D. Part D is quite nice in my opinion compared to part C because part D is pretty standard. The function h is defined by this, where k is a constant. All we need to do is find the range of values of k for which the equation h of x is equal to f of x. So all I have to do is equate my equations and solve for k. Oh wait, sorry, I forgot the last part. Has no real solutions. So you see, has no real solutions means your discriminant is going to be less than 0. And you can see that we're happy because it asks for a range, and if we have an inequality sign there in our discriminant, it's going to give us a range. So D, I'm going to set my equations equal to each other. So 2x squared minus 6x plus k, that's h of x, and that's equal to f of x. And then just solve. So bring that there, that's 5x squared minus 6x plus, and then that's k minus 4 equals 0. So that's a, that is b, and that is c. So b squared minus 4ac is less than 0. So I know that minus 6 squared minus 4 times 5 times by k minus 4 is less than 0. So that gives me 36 minus 20k plus 80, yep, minus, yep, negative make positive is less than 0. So then I have minus 20k plus 116 is less than 0. And I'm just going to keep solving it. So minus 20k is less than 1116 minus 1116. So k is going to be greater than 116 divided by 20. I flip the sign because I have a negative value and I'm dividing by a negative. So therefore, k is going to be greater than 29 over 5 as a simplified fraction, and that is my range of values for k. And that's all you have to do for 3 marks. So those were a nicer 3 marks, more intuitive 3 marks than the question C. But yeah, hopefully that makes sense. Awesome. I'm going to move on to question 9. Question 9 is a nice question in the fact that they combine geometric sequences with log laws, kind of, and it's a fun question to work through. I'd be happy if you got a question like this. So the first 3 terms of a geometric sequence are these, so I always like to put these underneath them so I know what they map to, where k is a constant. Using algebra and making your reasoning clear, prove that k is equal to 5 over 2. So they're giving us 3 marks and they're telling us the answer. So let's use this let's guarantee these marks. So whenever they give you values for a geometric sequence, the only thing you can really do is work with the ratios. So we know that AR divided by A, the ratio between the first two, is equal to the ratio between the second and the third. So AR squared divided by AR, because they all equal to R, right? The A's cancel and the A's cancel there, and 1R cancels here, so they're all equal to R. So we know that those ratios are the same. So literally just put your values, 9, 7 minus 2k, divided by A, which is 3, 4k minus 5, That's equal to 9, 7 minus 2k, and that is 3, 2k minus 2, a little bit of bracket expansion up there. I'm going to cross multiply here, and then use my index laws. It was index laws, not log laws, my bad. So we've got 9, 7 minus 2k, and if I multiply by the same base and a power, you add the powers. So plus 7 minus 2k, and that's going to be equal to 3 to the 2k minus 2, and then again I'm multiplying by the number with the same base, but so I will add the powers, plus 4k minus 5. I'm just going to clean up my powers now. So 9, 7 plus 7 is 14, minus 4k, and that's going to be equal to 3. 2k plus 4k is 6k, minus 2 minus 5 is minus 7, so 6k minus 7. And now I need to solve for k. So the way I solve for k, and this is exactly a GCSE type question, we want to take a log, we want to do a logarithm or just examine the powers. So we need to get the bases to be the same. We know that 9 is equal to 3 squared, so I'm going to rewrite 9 as 3 squared. 14 minus 4k equals 3, 6k minus 7. Then if you do a power and you're raising that to a power, you multiply across. So that's 3 to the 28 minus 8k equals 3 to the 6k minus 7. And now if I take log 3 of both sides, or literally just look at the numbers in my powers, I've got 28 minus 8k is equal to 6k minus 7. If I solve this, I have 35 is equal to 14k. Therefore, k is equal to 35 by 14, which is equal to 5 over 2. And that is exactly what I wanted. So that is 3 marks in the bag. So main things to know here are about the ratio bits of geometric sequences and how to deal with your index laws. Thanks everyone for the support in the chat and for all the likes. I appreciate it, guys. All right, let's keep going. So for part B, hence find the sum to infinity. So this should make you happy because it's a pretty standard formula of the geometric sequence. So we know that the formula for the sum to infinity is a over 1 minus r, probably one of the most easy formulas you need to memorize. So I'm going to first write out what my actual sequence is, knowing my value of k. So in my calculator, I do 3 to the power 4 times by 5 by 2 minus 5. And if I do that, I get 3 to the 5. So I just do that for all of my values. And if I do that, I have 3 to the 5, I have 9 squared, and I have 3 cubed. Evaluate those, you get 243, you have 81, and you have 27. So going from here, we have our r, and our r is going to be equal to 1/3 because you multiply by a third each time. So we know that this is our a, and we just plug it into the formula. 243 by 1 minus a third. If I put 243 over 2/3 into my calculator, I get 729 over 2, or as a decimal, 364.5. And that is my answer to the sum to infinity question. That is also 3 marks. In my opinion, that is a very generous 3 marks. But you know what? I'm not complaining. I mean, I didn't complain. So hopefully that makes sense, guys. I see no one has any questions on this one. So geometric sequences, we like. Can you explain 2 for 3 again? Sure, yeah. Sorry, I kind of like glossed over that fact. So what I did was, we have our sequence up here, right? But now we know that k is equal to, well, we knew initially that k was 5 over 2. So I literally just plugged it in. So over here, I did 4 times 5 by 2 minus 5. That's equal to 2 times 5, which is 10. That's equal to 3 to the power of 5. And 3 to the power of 5 is equal to 243. I just put k into my terms here and then evaluated what each term actually was. Hope that helps, Tyler. Okay, that is question 9. I see it is coming up to 8 o'clock, but I am probably going to run overboard with this live. Okay, question 10 is a integration question. This is not GCSE, this is A-levels, Fred. I did the GCSE live earlier. I'll try and post that on my YouTube as soon as possible. So I will keep this on my screen for a second for you to have a read while I just have a little drink. This live was scheduled to end, I think, at 8:30, but it may have to run on until 9, depending on how long this paper takes. I'm going to get through all these questions for you guys, but yeah. Okay, cool. Question 10. Very nice question in my opinion. So figure 3 shows a sketch of a part of a curve with this equation. The curve crosses the x-axis at point A, which is over here. Verify that the x-coordinate of A is 4. There are two ways you can do this. If you see verify, they sometimes generally allow you to use this answer in the equation. So you can, if you put in 4 here and here, and you compute that using your calculator, you will get that it's equal to 0, like the y value is equal to 0, and that proves it. When I did this, I did it the other way. I solved for it and showed it. Both are fine. So at y equals 0, we have 8x minus x to the 5 by 2 is equal to 0. So I'm solving for x, so I'm going to factorize that out. 8 and then minus x to the 3 over 2, because x to the power of 1 times x to the 3 over 2 is x to the 5 over 2, because 1 plus 3 over 2 is 5 over 2. That's going to be equal to 0. And then we know that therefore x is equal to 0, but that's not a, or 8 is equal to x to the 3 over 2, which is this part is equal to 0, and then just solve that x is equal to 8 to the power of 2 by 3, which is equal to 4. And hence we've proven that. Okay, very nice. Part B, L1 is a tangent to the curve at A. There's my little L1 running down the side over there, and it's a tangent, which means it touches using calculus. So this is year 1 differentiation. Show that the equation of the line of L is this. So we need to use calculus to find the rate of change of my curve, and then we plug in my point to find the gradient at that point. So very straightforward. So the tangent at A, which is at 4, 0. So we've got my curve, which is y equals 8x minus x to the 5 over 2. Yep. And I just have to differentiate this, which is pretty standard. Minus 5 over 2x to the 3 over 2. So you multiply by the old power, and you decrease the power by 1. That's a 3 over 2. Doesn't look like 1, though. We need it at this point, so dy by dx at x equals 4 is equal to 8 minus 5 by 2, 4 to the 3 by 2, and you plug that in, and you get negative 12 as your gradient. So then, as I saw in the chat earlier, y minus y1 equals mx minus x1. Y minus y1 is 0, so that's 1 minus 0. M is minus 12 because it's the gradient of a tangent. If it was a gradient of a normal, it would be the negative reciprocal of this as 1/12 for reference. And then x minus x1, which is 4. That's y equals minus 12x plus 48. Is that in the form they wanted? Nope, I just need to rearrange, bring my x's and y's onto one side. Therefore, 12x plus y is equal to 48. That is the next part. That was a nice little 3 marks. So nice question so far. And the question gets even better. It's very predictable because L2 has the equation y equals 8x. Let me just annotate here that that's 4. The region R is bounded and its curve is shaded. Using integration, find the exact area of R. So we see we've very clearly got a triangle of 0, 4, and we need to find what this height is. We can find the height using the intersection of our two straight lines. Then we find the area of the triangle. Then we integrate to find the area between the curve and the x-axis and subtract that. Exactly, trig. And then you subtract. So the area of the triangle first. So area triangle. The intersection of L1 and L2 is 12x plus 8x equals 48 because L2 was y equals 8x. So I used substitution there because it was easier. 20x equals 48, so x is equal to 2.4. I need my y value at that point, so y equals 8 times 2.4, and I get 19.2. So 19.2 is my height over here. So the area of the triangle is just a half base times height. So that is equal to a triangle equals a half times by 4 times by 19.2. Put that in my calculator, that's 2 times 19.2, and I get 192 over 5. So now I need to find the area between the curve and the line. So area under my curve, and I just need to integrate that. So I'm integrating between 0 and 4 because they told me a was 4. So what is my equation? It is 8x minus x to the 5 over 2. Yep. With respect to x. And this is very standard integration. So increase the power by 1, x squared, divide by the new power, a divided by 2 is 4. Increase the power by 1, that is x to the 7 over 2, divided by the new power, so minus 2 by 7. So minus was there, 4. and is definite, so we don't need a plus c. And then we have it from 4 to 0. We plug in our values, so 4 times 4 squared minus 2, 7 times 4 to the 7 over 2, minus, and then 0 minus 0, because if you put in 0 and 0 there, it's just 0. And then you have 192 over 7 as our area there. So therefore, r is going to be equal to the area of the triangle, which is 192 by 5, minus the area of the curve, which is 192 by 7. That's going to be equal to 384 by 35 units squared. And that's your answer to part C. Very nice question. Question 11 is nuts. Question 11, I'll give a little story for that when we get down to it. Hopefully it's not too bad. I'm usually decent, but this one's done with like 2 minutes. Okay, yeah, good luck for everyone tomorrow. Can I explain 19.2? Yep, 19.2. So I needed to find what my height was because I wanted to find the area of the triangle. So the area of the triangle is the base times by the height divided by 2. I needed the height, which is that point there. That point is where L1 and L2 intersect. So I found the intersection of L1 and L2 over here. So we found that it intersects at x equals 2.4, but I need the y value. So I know that y is equal to 8x, so 8 times 2.4 is 19.2. How we found the equation that we end up integrating? That's just this one. They gave it to us in the question at the top over here, and that's the equation of the curve. So that is this equation over here. So we integrate to find this area, because when you integrate, you find the area between the curve and the x-axis. Hopefully that helps, Isaiah. It is possible to go from a B to an A star in one night. You just gotta grind the hell out of your revision. No worries, Isaiah. Okay, cool. Going to move on to question 11. So I was part of the 2022 GCSE cohort who did that impossible circles question. You know, those 3 identical circles with the weird shaded regions, the one that went viral. So this question is it's like its sibling, it's version 2.0 of the impossible circles question. They just wanted to bring our trauma back to us for no reason. All of my friends and I, when we came out of this exam, were just talking about question 11 first, saying that it was identical to that. And because we all wanted to see how to do that GCSE question, we were fine with this, because there's just one trick you need to know, and I'm seeing it from Zion in the chat, which opens up this entire question. It's the fact that equilateral triangles are involved. In my GCSE, I forgot about equilateral triangles, so it made it harder for myself. But for this one, I remembered it, and it is basically, version 2.0 of the impossible circles question. I recommend having a go at that GCSE question, actually, if you have got time for revision, because it's very well an A-level question too. So we are going to get into the impossible circles question trauma 2.0. So figure 4 shows the design of a badge. The shape ABCOA is a semicircle with a center O and a diameter 10. So I'm just going to annotate there that my diameter is 10. OB is the arc of a circle with center A and radius 5. So OB, that's my arc of a circle with center A, so that's center, and radius 5. So I know that that is going to be equal to 5. I mean, that's obvious because O is the center of this circle, so it makes sense. Cool. We know that this is also going to be 5 because it's the radius. And we know that this is also going to be 5 because that's the radius of the bigger thing. And ta-da, we have our equilateral triangle. Let's keep reading though. The region R shown shaded in figure 4 is bounded by the arc OB, the arc BC, and the line OC. I mean, that's actually just what R is. Find the exact area of R. Give your answer in this form with a root and pi, where A and B are rational numbers. So let's get into it. So we know that the area of the shaded is the area of the semicircle minus the area of this white part. So I need to figure out how to find the area of this white part. So first I'll find the area of the shade of the semicircle to guarantee those easy marks. So we know that the area of a circle is pi r squared. So area of a semicircle is pi r squared over 2. And we know that r is 5, so that's pi times 5 squared over 2, which is 25 over 2 pi. And I'm going to underline that. That is one of the values I want to work with. I don't know why it's not switching colors, but never mind. Okay, cool. So now we need to work with areas of sectors and segments. That was the topic in the GCSE one, which I completely forgot existed, but it's quite obvious that it exists in A-level. So areas of sectors, which are slices, and segments, which is like fragment pieces. So we know that this is an equilateral triangle, meaning all the angles are the same. So the angle is equal to 60 degrees, but we're working with radians here. So we need to have 60 degrees as in radians, which is pi by 3, because we know that 180 degrees is pi radians, so 60 degrees is pi by 3. That's how you would convert. Okay, cool. So the area of sector. So I'm going to, this is how I'm going to work it out. I'll show you guys in advance with color. 1 second. I'm going to work out the area of this sector first, and then I'm going to work out the area of this segment, and then I'm going to add them, and then subtract that from our semicircle. That's how I will go about doing it. This is helpful for year 12 maths. Kind of. It is a year 13 topic with radians, but I mean, I don't see why not. The only difference is degrees for year 12. So we know that the area of a sector, the formula is a half r squared theta. Just plug in your values. A half times 25 times by pi by 3. That's 25 by 6 pi. Nice and straightforward. We know that the area of a segment, if you don't remember the formula, it is literally the area of a sector minus the area of a triangle. So the difference between sector and segment is a sector is like a slice, like a pizza slice, and a segment is this shaded bit off that pizza slice. So that shaded bit is found by finding the area of a sector, subtracting the area of that triangle. Hopefully that helps, Rehan. So area of the segment, A equals a half r squared theta, which is my area of my sector. And like I said, subtract the area of the triangle, which is a half r squared sine theta, because the area of a triangle is a half AB sine C, if C is theta, and A and B are the radius. It's just a half r squared sine theta. So I'm going to factorize out. Oh, great, everything disappeared. It likes to do that. So give me 1 second. Just give me 1 second. I will get my pre-written thing down. There we go. So here, I will do it in blue where we were. So area is a half r squared theta minus a half r squared sine theta. So I'm going to factorize out my half r squared to make it easier. So then I plug in my values. Theta is pi by 3 and sine of pi by 3. Sine of pi by 3 is root 3 over 2. So then I get 25 pi by 6 minus 25 root 3 over 4. So now I have my area of my sector, my area of my segment, and my area of my semicircle. And looking at my little, very nice little diagram here, the area of R, the shaded region, is the semicircle minus the sector minus one of that extra segment, which was this segment over here. So that's taking my values here, here, and here, and then just subtracting them. So 25 by 2 pi minus 25 by 6 pi minus this whole thing in brackets. That's equal to 25 by 6 pi plus 25 root 3 over 4. Is that in the form they wanted? They wanted like this, so a root 3 plus b pi. So we have 25 over 4 root 3, so this is a, plus 25 by 6 pi, so that is b. And that is in the form they wanted, r centimeters squared. So overall, hopefully that explanation wasn't too bad. Like it showed that this question wasn't so bad. It was funny because it was literally what they failed us in our GCSEs, but they decided to give it to us in A levels for 4 marks. But yeah, now that we have covered the area of sectors and segments more prevalently in A level maths, it is more obvious what we should do. It is easy to make a mistake, so just make sure you know what your values are, and if you lay out your working clearly like I did here, then you should be good to go. Like with the bullet points I find help, and my little squiggly underlines show me values I want to use because we can't use color. How do you know it is an equilateral triangle? Good question, because we know that this semicircle has a diameter of 10, so it's got a radius of 5. So going from this center up here is 5. They also tell me that this, and they have to tell me this, OB is the arc with a circle with center A. So this is also a circle with center A. So that's my center. It's got a radius of 5. So if I go from here to here, that is also 5. If I go from here to here to the outside of that circle, it is also 5. 5, 5, 5, equilateral triangle. I use the information they've given me and I annotate it onto my diagram. Yep, I will just zoom out. My God, my iPad keeps doing this. 1 second. It's very annoying when that happens. Okay, hope just get everything on the screen. There you go. Could you calculate? Oh, sorry, there's a question above that. Do you not need to take away the 2 segments? No, I don't need to take away 2 segments. Why? Because my 25 by 6 pi is my sector, so that includes that segment there, which is why I've only taken away once. If I did the area of my triangle instead, then I would need those 2 segments, but the sector includes this segment. No worries, Claudia. Could you calculate the area that needs to be removed with 2 times the sector minus? Yes, exactly, Edu. That's what yeah, exactly. Oh, there's a question up here. Yep, that's what it said. Perfect, no worries, Ollie. So, yep, that is the version 2 of the impossible circles question, which they love to give to us again. They knew we didn't like it, so they gave it again. Oh, they think they're funny. Okay, cool, very nice. Moving on to question 12. Question 12 is a very long topic. It's a very long question, but it's not bad. It's just long. I'm just going to keep this on the screen for a second while I have a drink so you can have a read through it. So this question is a pretty standard you're dying. Hopefully it doesn't die before the live stream. My iPad is dying too, so I'm gonna have to charge these at the same time. Okay, so this question is a standard trig question. If you understand how to work it through, hopefully this explanation will walk through a bunch of stuff you need, and then this is just a bit of problem solving as well. So, so express 140 cos theta minus 480 sine theta in the form k cos theta plus alpha. So this is harmonic form, where k is greater than 0 and alpha is between 0 and 90 degrees. State the value of k and give alpha in degrees to 2 decimal places. So all I need to do is use, if I've got cos of theta plus alpha, look, I've got 2 things in a bracket. That means I need to use the addition formula. So I need to express this like this. So I'm going to use an equation. So 140 cos theta minus 480 sine theta equals, using my cos addition formula, cosine addition formula, I get k cos theta cos alpha minus 4 plus k sine theta sine alpha. And what I do to make this very clear is I underline my cos theta there and my cos theta there. So I know that 140 equals k cos alpha. And I underline my sine theta there and my sine theta there. So I know that 480 equals k sine alpha. My negative and negative are just out there, but the important part is the k sine alpha. So I know that if I do the right side divided by the left side, we get k sine theta divided by k cos theta, the k's cancel, and sine alpha over cos alpha is tan alpha. That's equal to 480 divided by 140. So we have alpha is equal to tan minus 1 of 48 over 14, and you get that alpha is equal to 73.74 to 2 decimal places. So that is my alpha value, and I need to now find what my k value is. So I know that k is here, so k is equal to 140 divided by cos alpha, and plug in your full value for alpha in here, and you will get is equal to 500. Alternatively, you could find that k is equal to the square root of 140 squared plus 480 squared and get 500. I prefer to do it this way and then check using this way. That's how I did it in my exam. So I'm just going to write it out in that form. So therefore, we have 500 cos of theta plus alpha, which we know is 73.74 degrees. Okay, that is part A done. I think that's 3 marks. Yep, 3 marks for that. Nice little harmonic form to start off. Okay, cool. Now we got to use this and we got to understand how to use harmonic form. So a scientist studies the number of rabbits and foxes in a wood for 1 year. The number of rabbits, R, is modeled by this equation. If you look at this equation, this part is analogous to that part. So that's how we're going to use our harmonic form we've just found to make life easier for us. Where t months, and it's important that we know it's in t months, is the time after the start of the year, and a is a constant. Given that during the year the maximum number of rabbits is 1,500, find a complete equation. In other words, we need to find what a is, and hence write down the minimum number of rabbits in the wood during the year. How do you know it's a double angle? This is not double angle, it is addition formula, because you've got cos of something plus something in the brackets. So it's cosine addition formula. Okay, cool. So all we got to do is use our harmonic form and turn this ugly mess into this. So how do we get that? Well, we can see that theta is equal to 30t. So all we got to do is replace our theta there with 30t. So we have bi. They tell us the number of rabbits is equal to a plus that weird thing before, but we're replacing it now with 500 because we have that cos, but theta is now 30t plus 73.74. That's how you go from your harmonic form into this. Hopefully that makes sense. They tell us that the max is 1,500. Now, how do I know when the max value is? This is just trigonometry at the end of the day, guys, right? So we've got a cosine graph, and we know that cosine goes from 1 to -1. If you do something plus something, the maximum is when cosine, this thing, is at its maximum. So it's maximum at cosine of 30t plus 73.74. That is equal to 1, because cosine is from 1 to -1. That's just reference. Okay, cool. So we know that 1,500 equals a plus, this is maximum value of 1, so 500 times 1 is 500. So therefore, a is going to be equal to 1,000. So my complete form of my equation is r equals 1,000 plus 500 cos of 30t plus 73.74. So that's my answer to part 1. I think you could also, they allowed you to write it where you had 1,000 here and then this whole thing there. I think they allowed either one for your answer. Now, hence, write down the minimum number of rabbits according to the model. So we're going to use exactly the same logic. So we know that using our cosine graph, the minimum value is of cosine is -1. So our min is equal to 1,000 plus 500. And to make this as small as possible, we need to take away the largest amount. So it's got to be a negative, and it's got to be a very negative. So the smallest negative it could be is -1. So then that's just 1,000 minus 500 equals 500 rabbits. And that's it for part 2. So hopefully that makes sense. There's your problem solving with your trig. Just know the max and the min values of sine and cosine are 1 and -1, and see which one it is, positive or negative, gets you to have a positive or negative answer in the end, because it could sometimes be the opposite to what you want. Okay, nice. The actual number of rabbits is at its minimum value in the middle of April. Use this information to comment on the model for the number of rabbits. So basically, we need to verify that this minimum does indeed occur in the middle of April. So for part C, when it's at its minimum, we know that why am I doing that? We know that cosine of 30t plus 73.74 is equal to -1, like I said, because we want to take away a negative. So we know that 30t plus 73.74 is equal to cosine -1 of -1. And that means that 30t plus 73.74, because remember, that's just what's inside my cosine function, is equal to 180 and then 540 or blah, 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 because of the way that a cosine graph cycles. So it's there and there. But we want to verify that it's in the middle of April first. So we're going to solve for t. So I'm going to subtract 73.74, and then I'm going to divide by 30 to find what t is in one step. So t is going to be equal to 3.542 for 180, or it's going to be equal to 15.542 for 540. So now, what units is my t in? T, I made it very clear that it was in months. So t months, this is 3, so t is roughly equal to 3.5 months. And this is the important part, after the start of the year. Now we need to check, is that the middle of, I think they said April, right? So mid-April. Now check this carefully. So if we have the start of the year, which is this line, so this is New Year. After t equals 1, we're in Jan, so t equals 1 here. Then we have Feb at t equals 2. We have March at t equals 3. And then we have April at t equals 4. So here, this is the month of Jan. This is the month of Feb. This is the month of March. This is the month of April. So we can see that 3.5 is indeed in the middle of April. So 3.5 is mid-April. So now I need to comment on the model. So I can have my conclusion and then say, one second, let me just save this. Therefore, the model is valid or reliable or accurate because of my reason above. And that's how you do part C, which is not so bad. You just need to check and use the months of the year correctly. That's, in my opinion, the hard part of the question, knowing your months and how that works with the numbers. So let's check the chat. Don't worry, Lewis. This is the Edexcel exam board, Lewis. 76 out of 100 is not bad, Jay. Don't worry. It depends on your grade boundary, but should be fine with that mark now. Can you explain house in the middle of April? Yep, I'll explain that again. So this is my little diagram. I will just shift the month names actually a bit down because that's kind of deceiving. So we have the time from the start of the year because we need to read the question carefully. T months is a time after the start of the year. So if we look at my little calendar drawing down here, we have 3.5. So from t equals 0 to t equals 1, that is during the month of Jan. T1 to T2, Feb. T2 to T3, March. T3 to T4 is April. We had t equals 3.5, and then that's mid-April. Awesome. Okay, cool. We're still not done with this question yet, but in my opinion, the last part of the question is pretty nice. It's short, but is worth 4 marks. So, the number of foxes in the wood during the same year is modeled by this equation, where you got a sign thing going on there. The number of foxes is at its minimum value after t months. Find, according to the models, the number of rabbits in the wood at time t months. So you've got 2 things you got to do here. You got to first find what the value of t is. So that's when the foxes is at its minimum. And then at that t, find the number of rabbits, not the number of foxes. So we're doing exactly the same logic as before. So t months is the minimum when our sine function, so we have sine, and what did they say sine was? 30t plus 70. Sine 30t plus 70, and that's equal to, and I need to check, how am I going to get this to be minimum? Well, I'm doing 100 plus 70 times something, so this has got to be negative 1 to take away a big negative, is equal to negative 1. So 30t plus 70 equals inverse sine of negative 1, and you just draw that there for reference. So 30t plus 70 equals 0, 90, 180, 270. 270, so t is equal to 270 minus 70, which is 200, divided by 30 is 20 over 3 months. So now I found what capital T is. Now I need to check the question carefully. So I found the number of foxes after t months. I need to find the number of rabbits at time t months. So it's not hard. All I need to do is take my rabbits formula, R equals 1000 plus 500 times by cos of, and what was my rabbit's formula? 30t, so t is 20 over 3. 30 times 20 over 3 plus 73.74. Put that into my calculator and I get 1032.6 rabbits. And since it's a number of rabbits, we are going to truncate it and round down. So we get 1032 rabbits at t months, capital T months. They also allow you to get 1033 rabbits, but the principal answer they gave was 1032 because you can't have 0.6 of a rabbit, so you don't want to spawn an entirely new rabbit. That's why I rounded down. Okay, yep, t equals 3.5 is mid-April. 3 is at the end of March, exactly, so 3.5 is mid-April, 100%. You can round up and get the mark as well. They allowed 1033 as well for the mark. Why did I use negative 90 instead of 270? I did not use negative 90. Here. So here, negative 90 is the principal solution, but because I wanted it over here, I used 270. Oh, why did I use 270 instead of negative 90? Let me just check what happens if I do. Oh my god. 1 second. Let me just check what happens. Oh, that's beautiful. If I do negative 90, so I have sine minus 1 of 90, turn that into degrees of negative 1, and that gives me 90. So then I get negative, so I get negative 90 there, and if I subtract 70 from that, so I do negative 90 minus 70, I get negative 160, and I divide that by 30, I get this for my months, negative 16 over 3. And you can't have a negative number of months, so that's not possible. Exactly. This is pure paper 1. This is, I don't know why AI summary saying solving a GCSE maths problem on a rabbit population model. This is GCSE, then be in for a ride. Okay, cool. Nice. I think that is it for that question. Yep, very long question. Question 13, 14, and 15 get shorter. Question 15 is quite short. Question 14 is kind of short. It's another differentiation question. Question 13 is a lovely question, in my opinion. Well, it's an obnoxious question, but when I was doing this in my exam, I enjoyed this question. So I'm going to let you guys take a look at this question for a second and let me know what you guys think of it. Zion finds question 13 beautiful as well. It is beautiful. I like this question. I didn't like having it as a final because, I didn't want to mess up, but looking back at it, it's fun. If you like maths, you will like this question. I already covered GCSE content in the first half of the live for the first hour and a half, Elliot. I'm sorry, but I will post my live stream recording on my YouTube channel, same name as my TikTok page, a user, at the end, by the end of the night. Yeah, this is a good paper. This was 2024. This was my year's paper. Okie dokie. So let's get right into it. Half an hour left of this live stream. I know that we have come to time, but I am going to run overboard because I don't know why. I'm in charge of the time, so you know what? Whatever. Okay, cool. What do you think is better, past papers or topic questions for someone who's trying to cram? What I would do is read through the topic summaries and make sure you're happy with all the content, and then do some past paper practice, just so you can be aware of and exposed to the types of questions. However, the questions that appear in like the mixed exercises in the textbook are also very similar to these. Like that rabbits and foxes question, probably like almost straight out of a textbook, similar to that. Okay, cool. Let's start doing this question. Given that a is a positive constant, use the substitution x equals a sine squared theta to show that this integral can be written as this in terms of theta. So from x's to thetas. So you're doing integration by substitution. You have to do 3 things. You need to change your limits. You need to change the dx to a d theta, and you need to change the expression from in terms of x to in terms of theta. And as you go through that, it should be fine. It's the same rule each time. So for part A, this is the first part, we know that I'm going to do this part, d theta. So x is equal to a sine squared theta. So dx by d theta is going to be equal to 2a sine theta cos theta, because I'm using the power rule. You multiply by the old power, decrease the power by 1, and then you do the thing inside. So sine theta differentiated is cos theta. So I see a 2 sine theta cos theta, which is quite nice. I'm going to write down my rule for that on my side there, so I have that for reference. Now I want to rearrange for dx because I want to replace dx by d theta with something of d theta. So dx is going to be equal to 2a sine theta cos theta d theta. And I'm going to just clean this up a bit because I know 2a sine theta cos theta is the same as sine 2 theta, which is nice because I want a sine 2 theta. So therefore, dx is equal to a sine 2 theta d theta. So that's the first part done. You'll find that this whole question is just playing with a bunch of algebra, which is why I enjoyed it. So the second part is I'm going to do my limits. So at x equals 0, we have sine squared theta equals 0 because I've just plugged in 0 there and you divide by a. So therefore, theta is going to be equal to inverse sine of 0, which is 0. Okay, cool, that's my lower limit. Now I need to find my upper limit at x equals a, annoyingly. So a equals a sine squared theta, but it's not annoying because we can just see that sine squared theta equals 1. So therefore theta is equal to sine 1, and that's equal to pi by 2. So that is my upper limit, and also is right there. So they tell me, so I can verify that, yep, I have done it correctly. So cool, those are my limits. And now I'm going to rewrite my expression. So we've got the integral of 0 to a. So I'm writing the original thing first, x to the half of the square root of a minus x dx. If I rewrite that in terms of theta, I go from 0 to pi by 2, which were my new limits that I found. And then you do x to the half. So you know that x is equal to this, so you need to do this to the half. Let me just charge it real quick, 1 second. The screen is going to go up a bit, apologize. Just while my charger is underneath there. It's going to be a bit of a weird angle, but hopefully y'all can still see that. Take that back. Okay, cool. Question is there. Nice. I apologize for the lopsided angle. So you've got a sine squared theta to the half, and then here you have square root of a minus x, and we know that x is minus a sine squared theta. And then you've got dx. Well, we found what dx was. That is times by a sine 2 theta d theta. Very nice. I have replaced all my x's, my expressions, my limits, and my dx by d theta. So I just have to play around with this thing here and look at my goal. I have a half a squared and a sine squared 2 theta d theta in there. So I got to work my way through. So I'm just going to clean this up now. So let me just save. So first thing I'm going to do first is, let's see, I'm going to take the square root of this thing here first. So 0 pi by 2, I'm going to do this really slowly as I did in my exam. A to the half sine of theta times by square root of a, and I'm going to factorize out the a over here, so 1 minus sine squared theta multiplied by a sine 2 theta d theta. Okay, so far so good. And now I'm going to do a to the half times by a over there. So then that's 0 to pi by 2. So that's a to the 3 over 2 sine theta, square root of a, and then 1 minus sine squared theta. We should know from our basic trig identities is cos squared theta, which is very nice because that is a squared thing and I'm square rooting it, so I'm happy now, times by sine of 2 theta d theta. Now I'm going to clean up this square root thing here. So I've got 0 to pi by 2 of a to the 3 over 2 sine theta. And then that is times by a to the half times by cos theta. And then I have times by sine of 2 theta d theta. Like I said, this is a lot of just algebraic playing around with. Still, now I'm going to clean all of this up even more. So a to the 3 over 2 times by a to the 1 over 2 is a to the 4 over 2, which is just a squared. Then I've got sine theta cos theta sine 2 theta d theta. Now look at what we've got so far. This is very close to this. I've got a sine squared 2 theta, so I need to somehow get another sine squared 2 theta and a half. Look at this. You've got sine theta cos theta. You know that sine theta cos theta is equal to sine theta cos theta is equal to a half sine of 2 theta, and that gives me the last part of the thing I need. So this thing here, I'm going to rewrite that. You get the integral from 0 to pi by 2 of a half a squared sine 2 theta d theta. And I'm going to take out my half a squared, and I'm going to square this as the question wanted, which is equal to 0 pi by 2. Sorry, I forgot to take out, I just said I would. Equal to a half a squared, 0 to pi by 2. Sine 2 theta times sine 2 theta is sine squared 2 theta with respect to theta, and that is your answer. Very satisfying question, in my opinion. If you like maths, which I hope you do, then you will get this question. This is A level. But yeah, this is very nice substitution question. I don't know why the AI summary is saying solving a tricky GCSE question on integration. But yeah, and you have the answer there, so you can check. You can verify those 4 marks. Okay, cool. Hence, using algebraic integration, show that the integral of this thing is equal to k pi a squared, where you need to find k. So all you got to do is use the right-hand side and integrate that. And we know how to integrate the right-hand side. So part B, even if you couldn't do part A, don't worry, because they give you the answer to use in part B. And it's also 4 marks. So for part B, let's take a breath. From 0 to a of x to the half of square root of a minus x with respect to x, that is equal to 0 to pi by 2. That is equal to a half a squared. That's what I've just found. Of sine squared 2 theta d theta. So I need to integrate this thing here. You cannot integrate sine squared of theta or 2 theta directly, so you need to use the double angle formulas to convert the sine squared back. So you know that cos of 2 theta is equal to cos squared theta minus sine squared theta. But in terms of, we don't want any squareds. So let's just find one where we have sine squared theta and just cos 2 theta. Well, we know that cos 2 theta is also equal to 1 minus 2 sine squared theta. I want sine squared of 2 theta. So if I rearrange this, bring this here and bring this here, I have 2 sine squared, and I'm going to say 2 theta now, equals 1 minus cos 4 theta. I've just doubled my thetas. And then sine squared 2 theta is equal to a half minus a half cos 4 theta. Very nice. And I can just substitute that in over here and integrate that more easily. So if we do half a squared of 0 to pi by 2 of a half minus a half cos 4 theta with respect to theta, and now we can easily integrate this with respect to theta. So we have a half a squared of a half theta, and then this one, cos integrates to sine, so you have sine 4 theta divided by 4 minus 1/8 of pi by 2 using the reverse chain rule of pi by 2 to 0. And now all we have to do is substitute in. So we have a half a squared of pi by 4 minus 0. If I sub in pi by 2 into these, take away, and then 0 subbed in gives me 0, so 0 minus 0. And I get half a squared times by pi by 4, which is 1/8 pi a squared, where k is equal to 1/8. And that is your answer to part B. Nice question, in my opinion. It's a lot of algebra, very algebra heavy, but I like algebra, which is why I found this a nice question. Can you show the whole thing? Yes, sure. Let me just also position this a bit more nicer. Okay, this is the part A. So if you want to take a screenshot of my kind of messy working, feel free. And then part B over there. Okay, cool. Now I will rest my phone on charge again at an angle. It's at an angle because my phone is on charge and the wire is like jutting it out. But yeah, for 8 marks, not so bad. I'm just going to check the chat. Let me just see, is this fine for everyone? This is I mean, you can't really use a calculator for this type of question. Thank you all for the likes, guys. I appreciate it. And for the gifts. That's really nice of you all. Okay, cool. Very nice. Very nice. Moving on. 2 questions left with 17 minutes. We're doing good for time. I'm actually stuck to the time. It's pretty nice. Okay, question 14, guys. We have another differentiations and differential equations question. This paper was blessed with calculus when I started. Okay. A balloon is being inflated. In a simple model, the balloon is modeled as a sphere. That is a very sad balloon. The rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. We got to put that into symbols because that is just nonsense as words. So the rate of increase of the radius means the rate of change of the radius, which is dr by dt. The rate of change is d something by dt. It is inversely proportional, so it's one proportional to 1 over something, inversely proportional to what? The square root of the radius. So that is literally what that is in symbols. Very basic. At time t seconds, the radius of the balloon is r centimeters. Write down a differential equation to model the situation. Well, we're almost there. We've done literally step 1. So A, we have dr by dt is proportional to 1 over square root of r. So we have that dr by dt is equal to k over square root of r, where k is a constant. And that's it. That's part A done. That's 1 marker. It's kind of like GCSE type question. The only thing you need to do is read this and put a constant instead of a proportionality. That's your constant of proportionality from GCSEs. At the instant when t equals 10, so that's your t, the radius is 16, and the radius is increasing at a rate of 0.9, so that's dr by dt. That's what I did in my exam. Write down the letters next to your numbers. So for part B, we need to solve the differential equation there to show something of r. Okay, nice. We're solving another differential equations question. So we have our boundary conditions that t equals 10, r equals 16, and dr by dt is equal to 0.9. We know that dr by dt is equal to k divided by r to the half. So if we integrate this, we are going to separate the variables. That's how you solve a differential equation. So everything with r's are on the left side, and everything without r's, with t's, are on the right side. So we have r to the half of dr equals k dt, and we can integrate both sides. One with respect to r, the other with respect to t. So increase the power of r, so it's r to the 3 by 2 divided by the new power, 2/3 r to the 3 over 2. That's equal to kt plus a constant c. Why do we do r to the half? Because it's square root of r, so square root of r is equal to r to the half. I just rewrote it to make my integration much easier, Jay. Okay, cool. Now I need to find out what c and what k is, because I need to solve and show actual values. So, and this is for 5 marks, and they give me the answer, so I'll know if I got those 5 marks. So use your boundary conditions. At t equals 10, we have that 2 over 3 to the, sorry, was it t equals 10? Yeah. 2 over 3 times r, which is 16. So 16 to the 3 over 2 is equal to 10k plus c. And we know that dr by dt is equal to 0.9, and that's equal to k by square root of 16, just using my formulas. So these are the 2 equations that I have. I've got 2 unknowns, so I need 2 equations. Now I've got to solve for them. So here, this is easier to solve because I've just got 1 unknown. So going down here, I have that, therefore, k is going to be equal to 18 by 5. Because I've got k is k over 4. 4 times 0.9 is 18 over 5. So if I plug in my k value over here, there, I have 2/3 of 16 to the 3 over 2 equals 10 times 18 by 5 plus c. I've got 1 unknown, which I can easily solve for. So if I plug all this into my calculator, I do this, subtract this, I get c is equal to 20 over 3. Doesn't matter which side you put the plus c on. No, it does not. You can put it on either side. You can even put it on both, I think. Don't quote me on that, I think. But I like to put it on the right-hand side once, because that's my constant of integration overall, which has disappeared from my overall equation. So this is what I do, and this is the standard way of doing it. The left side doesn't have a plus c, but the right side does. Just as a notation shortcut. So I have c and I have k. Now all I need to do is put them into my general equation. So I know that 2/3 of r to the 3 over 2 is equal to k, which is 5.4. Is that what 18 over 5 is? Let me just check. 18 divided by 5 is 3.6, not 5 over 4. Is 3.6. T plus c, which is 20 over 3. Is that in the form they wanted? They just want r on its own, so I'm going to divide by 2/3, so multiply by 3 over 2. So therefore, I get r to the 3 over 2 is equal to 5.4. There's the 5.4. T plus 10. And that is how you do part B of the question for a nice 5 marks with the answer given. So that one, again, just solving a differential equation, separating the variables. I am very sorry that this is lopsided. It must be bugging you. Okay, there we go. Now it's straight. So all we have to do is solve a differential equation, separating the variables, bring the r terms onto the left side, and the non-r terms, the t terms, onto the right side. Integrate both sides, have my constant integration on my right side to make it easier. I've got two unknowns, c and k, so I need two equations, one in terms of r and one in terms of dr by dt. Solve for k, solve for c, plug back in, get into the form they want. Okay, that's the little summary of that. Part C and D are very nice. Hence, find the radius at t equals 20. Give your answer to the nearest millimeter. Let's just check. The radius is in centimeters, so r is in centimeters. They want it in millimeters. So we gotta be careful with our units. So C at t equals 20, r to the 3 over 2 is equal to 5.4 times 20 plus 10. Even if you can do part B, you can do part C because they give the answer to part B there. So that is going to be equal to 118. So r is going to be equal to 118 to the power of 2/3 because you will square both sides and you cube root both sides. So you have that. That's equal to 24.057 blah 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 centimeters. They want it in millimeters. We know that 10 millimeters equals 1 centimeters. So to go from centimeters to millimeters, we multiply by 10. So that's equal to 240.57 blah 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 millimeters. And what do they want it? To the nearest millimeter. So we just have to round this. So looking at that, that rounds up to 241 millimeters. And that is the answer to part C. Hopefully that makes sense. I can see that this one lopsided again. There we go. Nice. Part D is where I got excited in the exam and I put an exclamation mark. Suggest a limitation of the model. So this is what I wrote. D. So if you're trying to talk about limitations, go talk about extremes. So as t tends to infinity, what does your model tend to? R, what does that tend to? Plug in increasingly large values, and you'll find that R also tends to infinity. So i.e. the balloon gets infinitely large. And so this is unrealistic because at a certain time, the balloon is likely to pop. And I put the exclamation mark there to be dramatic. So yeah, this model is the limitation is that it says that the radius is going to keep increasing, but we know that's not true because it's a balloon, right? And in real life, a balloon is just going to pop. So hopefully that makes sense. Nice little, to be dramatic. So yeah, I mean, it was towards the end of my paper. I was feeling it. Okay, cool. Could you not do t equals 0 and r equals 16 to find c? T equals 0. So if t equals 0, r equals 16. Yeah, that is another way of getting c as well. But no, wait, sorry, no, you cannot do t equals 0 and r equals 16. Hold on, because at the instant where t equals 10, the radius is 16. At t equals 0, we don't know what the radius is, so we cannot do that. Hence, we need to use these. Could you say that it's modeled as a sphere, so it's inaccurate? Let me just, on my other device, let me pull up the mark scheme and see if that's part of the thing. Let me just check 1 second. So, because that is technically also a limitation of the model, I agree. Let me just see what they say for that. For part Yeah, so the examples of acceptable answers which must relate to the model in context say that the model will not hold indefinitely as the balloon may pop. That's like the principal answer they give. Then they also say the balloon is unlikely to be perfectly spherical, condone circular. So that is also allowed. So yeah, you can say it's modeled as a sphere, so it's unlikely to be perfectly spherical. Why is a sphere inaccurate? Because it's a modeling assumption. The balloon, they're not saying the balloon is a sphere, they're saying the balloon is modeled as a sphere. So whenever you talk about criticizing these things, you have to see where have they made a modeling assumption and then criticize that. Another thing they say is that the model predicts the balloon will increase in size without limit, which is unrealistic, and that is exactly what I wrote in the exam. So that's, as you can see, it'll pop. No worries, Amelia. And balloons can be different shapes. So yeah, balloons can be different shapes. Here, they're not saying it is a sphere, they're saying it's modeled. That's the reason. This is 2024, sorry. Okay, cool. That is part D. 6 minutes left, and we've got question 15, last question. You want to see part A again. Okay, 1 second. There's part A. So for question 15, I always find that the last questions of the maths exams tend to be the proof question. And this proof was unique. I've never seen this type of proof before, so it's unlikely they'll give it to you, but it's good to go through just so you know. No worries, I'm dying. So you have an idea of how to work through these types of questions. So it's two proof questions, there's two parts. So no worries, following along, I like that. So for 15, part 1, show that this is positive for all real values of k. How am I going to show it's positive? Well, I need to show that that is never negative. So I've got my function k squared minus 4k plus 5, and I'm going to complete the square. So I have k minus 2 squared minus 4 plus 5, and that's equal to k minus 2 squared plus 1. Now, how am I going to show that this is positive? Well, we know that anything squared is always going to be greater than or equal to 0. So we can just say k minus 2 squared is greater than or equal to 0 for all real k, because they say for all real values of k. Therefore, k minus 2 squared plus 1 is always going to be greater than or equal to 1 for all real k. Therefore, k minus 2 squared plus 1 is greater than 0. So, k squared minus 4k plus 5 is always positive. So that's how I did the first part of the question. Can you use the discriminant? Discriminant, you can use b squared minus 4ac, and then you can show that the number of roots. Actually, wait, no. Let me just check. You've got minus 4 square 16 minus 4. Let's just write that out. 16 minus 4 times by that is equal to 10. No, I don't think you can use a discriminant on this one straight away. But because you're trying to show it's positive. Hold on, wait, no, yeah, that's fine, you can. What am I saying? 16 minus 20 is less than 0, therefore no real roots. I don't know what I was saying. I was like, hold on, this should work with the discriminant. Yeah, it can work. So b squared minus 4ac is negative 4, which is less than 0. There, you can say, therefore, there's no real roots. So it is positive as it never crosses the x-axis. Apologies. Yeah, so you can use the discriminant. Where did the minus 4 come from in the first part? The minus 4 came from completing the square, k minus 2 whole squared, and then you subtract the minus 4 from that. Okay, cool. So I will just rub out the... Actually, no, I don't know why I'm doing that. I will keep that. So that is an alternate method. Okay, cool. For part 2 is quite long. it's very waffly and very long. So a student was asked to prove by contradiction this: there are no positive integers x and y such that this is equal to 28. The start of the student's proof is shown below. Assume the positive integers x and y exist such that this, so you do your negation. If 3x plus 2y equals 14 and 2x minus 5y equals 2, then you've got this and this, so x is equal to that, and they are not integers. X and Y are not integers. So we need to show the calculations and statements needed to complete the proof. It is a very long and repetitive proof. So I'm just going to pull up the thing I wrote beforehand because it is, you guys will understand the point if I explain it once. So when I was practicing, here we go. So they found factors of 28 as 14 and 12. So what I did was I listed all the factors of 28. You've got 1, 28, 2, 14, 4, 7 as the factor pairs. And then you basically just rewrite what they've done here 6 times. Yeah, for each of the factor pairs. And then show what x and y are equal to. So for 1 and 28, 28 and 1, you have those values for x over here. Then I did 2 and 14, 14 and 2. 14 and 2 was what they did already. I just put given, and here, this is not, these are both integers, but they want them to be positive integers, so I said this was not positive. And then I did the same for 4 and 7 and 7 and 4, and then found those. So none of these x's and y's are positive integers. And then I need to see what other values of x and y's are possible. Well, I can see in all other cases are not possible because 3x plus 2y have got to be greater than or equal to 5. Because why? X plus y, x and y are positive integers. So they must be 1 or greater. So that's going to be greater than or equal to 5. So these are all contradictions, as none of the solutions return positive integers for x and y. So it's an obnoxious amount of work for 4 marks, the number of times I had to plug in this into my simultaneous calculator thing. But it's repetitive, it's just long, and you need to know to do the factor pairs, and you also need to state this about all other cases, and then you need your conclusion. These are all contradictions, as none of the solutions return positive integers for x and y, and therefore, then I just state what the original thing we were trying to prove was. There are no positive integers x and y such that 3x plus 2y times 2x minus 5y is equal to 28. And that is a wrap on the A-Level 2024 Paper 1. I hope I explained this stuff well. I hope you guys understood the explanations and hopefully kind of enjoyed it. What do you recommend doing tomorrow before the exam? What I recommend is doing the weak topics. If you are weak on a topic, make sure you have mastered that. Like, if you are confident in some topics, good. Don't waste time going over those for too long. Make sure you understand the weak topics too, just to maximize the number of potential marks you can get. No worries, Ollie. Thank you all for liking the live and for sending all your gifts throughout, for interacting and engaging with me. I really appreciate it. Do let me know how your paper goes and how it, like, what comes up and stuff, and if what I said was useful. Hopefully you guys remember that and do it in the exam. Like, feel free to DM me or put in my comments. Learn all the trig graphs, exactly. Learn the sine, cos, tan, arcs, and reciprocals too. Make sure you know about their domains and ranges. No worries, Jasmine. I'm planning on doing another A-Level live stream next week for the paper 2 exam, so I will release the date soon, shortly, in a few days. But yeah, I'll just hang back for another like 1 or 2 minutes if anyone wants to say anything or stuff. But yeah, hopefully it goes well for you all tomorrow. I look forward to hearing how it goes, and I hope this live helped you out. Yeah, I'm here if you want to ask questions. Question 14, I got confused with the wording for part A. I'll go down there. Triple angle formula worth knowing or not? It's not in the spec. I don't think so, so I wouldn't. So let me just go down to question 14, right? It's a very long paper. Question 14 for part A. The wording, yeah, so just break it up slowly. The rate of increase of the radius is dr by dt. Is inversely proportional. So it's proportional to 1 over something, the square root of the radius. So that square root of the radius is the denominator. That's how you'd work it through. Blah, blah, blah. So for convergent, and so that's to do with like the sum to infinity. So if you have n getting larger as n tends to infinity, s of n also tends to infinity, is divergent. It doesn't go towards a number. So that's what divergent is. Convergent means that as n tends to infinity, the sum gets closer to a finite value. It converges to a finite value. So a geometric series is convergent if the modulus of r is less than 1, where r is the ratio. That's what allows us to have a sum to infinity. So converging sequences or converging series are ones where it tends towards a finite value. The name of the topic of question 14, I think that's in the differentiation. I have the textbook. Let me just pull up the name. It's the last part. It's called rates of change, 9.10 in the textbook. So the first part, topic 14a, is rates of change, and then they combine that with differential equations, exactly like what I said. Yep. This is A levels, Ferrari. Yep. Differential equations, exactly. Differential equations, and they're used with rates of change. Okay. Good luck with your exam tomorrow, guys. Let me know how it was. I hope it goes well for you all. Okay. Good night. Bye bye.